Good morning, everybody, and welcome to the second day of the Second International Virtual Congress and 2022 Philippine Agriculturists Summit. Our program will begin in a few minutes.
is one of the world's mega diverse countries, rich in natural resources and biological diversity. The very reason why agriculture, marine and aquatic, and natural resources are foreseen as key sectors in achieving sustainable and inclusive development in the country. With the right policies and programs in place, backed with appropriate technologies and innovations, attaining development is not far from reach. This is where the Philippine Council for Agriculture, Aquatic and Natural Resources Research and Development, or PICARD, takes its ground. PICARD was established in 2011 through the merging of two sectoral councils under the Department of Science and Technology: the Philippine Council for Agriculture, Forestry and Natural Resources Research and Development, and the Philippine Council for Aquatic and Marine Research and Development. Consolidating these two organizations into one apex council broadened its coverage, as well as provided a unified and holistic approach in addressing concerns in the agriculture, aquatic, and natural resources, or AANR sector. The Council aims to provide strategic leadership in promoting science and technology, or S&T, as a platform for AANR products innovation and environmental resiliency. Committed to sustaining dynamic leadership in S&T innovation in the AANR sector, PICARD formulates policies, plans, projects, and strategies for S&T development in the AANR sector. It programs and allocates government and external funds generated for research and development, or R&D efforts, as well as monitors R&D projects. It also generates external funds for R&D activities. PICARD carries out programs and advocacies according to 4 banner programs that embody its S&T interventions in the AANR sector. These are strategic R&D, R&D results utilization, policy research and advocacy, and capability building and R&D governance. The Council partnerships with local and international organizations for joint R&D, training, technical assistance, and information and technology exchange. It also ties up with funding institutions to support its programs and advocacies. Through the years, PICARD has been a lead organization in managing the network of government and higher education institutions involved in the AANR sector. Guided by its core values of relevance, excellence, and cooperation, PICARD catalyzes development through advancing S&T in the AANR sector. It is steadfast in its commitment to its mandates for the betterment of the lives of every Filipino, now and in the generations to come.
We are Filipino by design. Our roots have attuned us in promoting agricultural sustainability through sheer Philippine ingenuity. We are driven to progress. Back in 1997, our group of less than 20 staff and field employees had to face financial limitations and market concerns where we had to prioritize funding only in select areas. Armed with only 2 products and constantly anxious over unguaranteed success, we faced industry giants coupled with an unpredictable and overcritical market. This is why reaching 25 years is not due to a stroke of luck. Our founders focus on their dreams to support the Filipino farmer set up his entrepreneurial goals for a sustainable livelihood. Our vision of a developed society is rooted in an agricultural system that thrives amidst calamities and global pandemics. Thus, we collaborate and cooperate with groups that share the same goal. New opportunities excite us. Every day, we discover new opportunities that expand our capacity for growth. In our earlier years, we founded Leeds Environmental Health Products Corporation and Leeds Animal Health Corporation, which are agriculture-related companies that cater to markets beyond rice and vegetable farming. Prime Stocks Chemical Corporation and Golden Prime Stocks Corporation focused on streamlining the production and selling of high-demand products. By our 20th year, we decided to serve different aspects of the farmer's value chain. We started Leeds Tech Corporation for agri-machinery, Leeds Agri-Ventures Corporation for the production of quality seeds, and Leeds International Corporation to address rice consumer demand. The year 2020 saw us reach unprecedented heights when we surpassed 2 billion pesos in sales. This encouraged us to widen our reach and tap into the real estate industry through Malveda Properties and Development Corporation, which is geared towards development programs for smart city living. We take civic duty seriously. We launched Leeds Diagnostics to give back to the communities that have supported us into the company we are today. We are excited to launch our medical missions and outreach programs that will be accessible to even the smallest farming communities anywhere in the country. From a small company initially overlooked by the industry and that barely hits their growth targets, we now have more than 300 employees serving over 1,000 agricultural dealers and distributors, which equip millions of Filipino farmers with the right tools and technology nationwide. With an experienced portfolio that covers multiple industries, we continue to expand the dream started by Filipinos for the Filipinos.
Good morning, fellow Philippine agriculturists. Welcome to the second day of our International Virtual Congress and 2022 Philippine Agriculturist Summit. May we all blessed by the good Lord for this day as we continue with our virtual Congress. For this morning's activity, we will have the poster presentation, and this will be moderated by Dr. Ronnie De Castro, the chair of the poster presentation. Don't forget to sign up on the attendance sheet that will be provided later on, and hope that you will enjoy the poster presentation of our selected participants. Okay. Um, at this point, I will turn over the proceedings to Dr. Ronnie De Castro for the poster guidelines presentation. Dr. Ronnie, good morning.
Thank you, Sermon. Good morning, and I'll be your moderator for this morning's activity. So, allow me first to present some guidelines for the poster presentation this morning. So, this is our guidelines. So, please note for our presenters, please note the time of your presentation and make sure to log in the StreamYard 10 minutes before the scheduled time of your presentation. And please do not share the link that we use for this presentation. Second, kindly make sure that your complete registered name will be used when entering the StreamYard for easier identification. And during the presentation of your poster, the host will play your recorded video, and this will be followed by a 15-minute question and answer. And then during the question and answer, we will give priority to our invited judges. I will introduce them later. We will prioritize for our invited judges to give questions first. And then after that, we will check the uh, questions of the participants in the Facebook and YouTube. So the participants in the Facebook and YouTube, you may post your question in the comment or chat box. And then after the question and answer, the host will automatically remove you, the presenter, from the StreamYard to give way to the next presenter. So that is our guidelines for this poster presentation. Now, to introduce our invited judges, so we invited three judges from different fields. So first is Engineer Joseph and M. Sandro, and he is from the International Rice Research Institute, or IRI. Currently, he is the sa- uh, uh, assistant scientist on the agricultural engineering under the Climate Adaptive Agronomy and Mechanization Cluster Sustainable Impact Platform of IRI. Our next judge is from the Institute of Crop Science, College of Agriculture and Food Science, UPLB. She is Miss Anne Malulex Magnaye, and her expertise is on agronomy and currently working at UPLB as university researcher. And lastly, our third judge is Mr. Michael Francis Falconi. He is a environmental and social safeguard specialist from the Department of Agriculture, specifically under the Philippine Rural Development Project, or the PRDP. And he is also involved under the UNDP GEF DNR project on uh, implementing the national framework on access and benefit sharing of genetic resources and associated traditional knowledge in the Philippines. So that there you have it, our three judges. So we will meet them live later during the question and answer. Thank you. So to introduce our uh, first poster presentation. So the title of our first poster is Enhancing Rice Productivity in Rain-Fed Lowland Using Modern Production Technologies. This will be presented by Mr. Melvin S. Andres of the Philippine Rice Research Institute, Batac, Ilocos Norte. Uh, the other authors of this paper are Ms. Rica Meiji Gomez, Ms. Leilani Juliano, Mr. Dindo King M. Donaire, and Mr. Ailon Oliver B. Capestrano. So this is our first poster, and we will start the poster presentation at exactly 8:30. Thank you.
We are Filipino by design. Our roots have attuned us in promoting agricultural sustainability through sheer Philippine ingenuity. We are driven to progress. Back in 1997, our group of less than 20 staff and field employees had to face financial limitations and market concerns where we had to prioritize funding only in select areas. Armed with only 2 products and constantly anxious over unguaranteed success, we faced industry giants coupled with an unpredictable and overcritical market. This is why reaching 25 years is not due to a stroke of luck. Our founders focus on their dreams to support the Filipino farmer set up his entrepreneurial goals for a sustainable livelihood. Our vision of a developed society is rooted in an agricultural system that thrives amidst calamities and global pandemics. Thus, we collaborate and cooperate with groups that share the same goal. New opportunities excite us. Every day, we discover new opportunities that expand our capacity for growth. In our earlier years, we founded Leeds Environmental Health Products Corporation and Leeds Animal Health Corporation, which are agriculture-related companies that cater to markets beyond rice and vegetable farming. Prime Stocks Chemical Corporation and Golden Prime Stocks Corporation focused on streamlining the production and selling of high-demand products. By our 20th year, we decided to serve different aspects of the farmer's value chain. We started Leeds Tech Corporation for agri-machinery, Leeds Agri-Ventures Corporation for the production of quality seeds, and Leeds International Corporation to address rice consumer demand. The year 2020 saw us reach unprecedented heights when we surpassed 2 billion pesos in sales. This encouraged us to widen our reach and tap into the real estate industry through Malveda Properties and Development Corporation. which is geared towards development programs for smart city living. We take civic duty seriously. We launched Leads Diagnostics to give back to the communities that have supported us into the company we are today. We are excited to launch our medical missions and outreach programs that will be accessible to even the smallest farming communities anywhere in the country. From a small company initially overlooked by the industry and that barely hits their growth targets, we now have more than 300 employees serving over 1,000 agricultural dealers and distributors, which equip millions of Filipino farmers with the right tools and technology nationwide. With an experienced portfolio that covers multiple industries, we continue to expand the dream started by Filipinos for the Filipinos.
Okay. Good morning. And again, here is Mr. Melvin Andres of the Philippine Rice Research Institute to deliver his paper, Enhancing Rice Productivity in Rain-Fed Lowland Using Modern Production Technologies.
Greetings to everyone. I am Melvin S. Andres, a researcher from the Philippine Rice Research Institute, and it's an honor to present to you our research output titled Enhancing Rice Productivity in Rain-Fed Lowland Using Modern Production Technologies. This project is under the research banner program of DA Phil Rice being implemented in Ilocos Norte. Rain-fed lowland rice farming in the country is affected by many abiotic and biotic factors resulting in low productivity. Most common problems in rain-fed areas is water scarcity, which directly related to poor land preparation, uh, transplanting of older seedlings with infestation and delayed fertilizer application, and consequently increases the cost of production. Other problems includes the occurrences of insect pests and diseases, and lack of access to new and modern rice production technologies such as new variety farm machineries like mechanical transplanter, combine harvester, and appropriate nutrient, water, and pest management strategies. To alleviate problems in the rain-fed areas, modern packaging technology was evaluated to increase productivity and profitability of rice farmers and help reduce their production costs. This study aims to evaluate and package the modern rice production technologies for favorable rain-fed lowland environment. Specifically, it aims to assess the performance of rice using the modern POT with varying mowet-based nutrient management and compare to the existing farmers' practice in the locality. For the materials and methods, this figure shows you the conceptual framework of the study evaluating the modern POT compared to the farmers' practice through the establishment of field trials. The project was implemented in the city of Batac, Ilocos Norte on 2021 wet season cropping in 6 sites. A 1,000 square meter plot for each mowat recommendation was implemented, including a farmer's practice being managed by the farmer in the community or in the adjacent field. Data were analyzed using the randomized complete block design at 5% level of significance. The modern rice POT evaluated on-farm uses recommendations in different crop management areas as follows. For the variety, we use NSIC RC402 at 30 kilogram per hectare seeding rate. The land preparation, we make sure that the field was well leveled. For the crop establishment, we utilizes the mechanical transplanter following the 30 by 15 centimeter planting distance and younger seedlings ranging from 14 to 18 days after sowing. For the nutrient management, we use mowet-based fertilizer recommendations with 5, 6, and 7 ton per hectare yield targets, alternate wetting and drying for the water management, integrated pest management, and combined harvesting and harvesting at the right time for the harvest management. During the evaluation of the on-farm trials, agroclimatic condition was observed and recorded. Data on agroclimatic parameters or agroclimatic condition was generated from the MMSU Agromet Station based in Batac, Ilocos Norte. Results revealed that the rainfall were unevenly distributed during the rice growing period, with in-season drought resulting in the application of supplemental irrigation, especially during the scheduled fertilizer application. Moreover, high relative humidity peaking at 98% and low solar radiation were also observed in the field setup during the crop growth and development. In terms of the nutrient management, this table or the table 1 shows you the fertilizer rates applied in the field trials based on the MOET recommendations and the farmer's practice, where it averages about 132 10 91 kilogram NPK per hectare for 5 ton yield target, 173 10 91 kilogram NPK per hectare for 6 ton yield target, and 219 10 91 kilogram NPK per hectare for 7 ton yield target under the modern POT, which were applied in 4 splits, compared to the farmer's practice with 124 40 65 kilogram NPK per hectare, which applied only in 2 splits. So in figure 2, present to you the sample MOET setup indicating that nitrogen, phosphorus, and sulfur as the most common deficient elements in the study sites. Upon knowing the abiotic factors affecting the field trials, let's also focus and discuss on the field performance of the modern POT and the farmer's practice. So results revealed that the modern POT produced significantly higher yield than the farmer's practice across 6 sites based on the actual yield and the crop cut yield, obtaining zero point 0.7 to 1.2 tons per hectare yield advantage or an equivalent of 13 to 21% based on the actual yield. Higher yield was attributed by the use of high-quality seeds of a performing variety, including with the use of a mechanical transplanter, which enables the timely crop establishment using younger seedlings, along with the use of combined harvester that reduces the post-harvest losses. Also, the contribution of the appropriate nutrient, water, and pest management was also associated in the higher grain production. Meanwhile, the Mowat recommendations achieved the target yields for 5 to 6 ton per hectare. The achievement of the 7 ton per hectare was limited by soil and other constraints such as the devastation of Typhoon Marine during the during the reproductive stage and even in season drought during the vegetative stage. But the actual yield of 6.11 to 6.43 tons per hectare was also achieved in the three project sites. Significant differences were also observed on the yield components, such as number of tillers and panicles per unit area, including the harvest index across the treatments. And associating the yield and yield components of the modern POT and FP, analysis revealed that the grain production was positively correlated with the tiller number of panicles per unit area, and weight of 1,000 field grains. So a relatively strong association between the yield and these parameters were observed, indicating that every increase in the yield is affected by the increase in the number of tillers and panicles per unit area, including the weight of the field grains. Moreover, production analysis also reveals that the cost of producing rice per hectare ranged from 56,012 pesos to 63,765 pesos, uh, based from the modern package of technology. Increasing production costs for the three yield targets is directly influenced by the amount of fertilizer used. But compared to FP, the POT obtained lower production costs by 1 to 13%, with a reduced cost per kilogram produced by 3.15 to 3.71 pesos. So the lower production cost was attributed by the use of transplanter, mechanical transplanter, which reduces the cost of crop establishment, and also the use of combined harvester, which reduces post-harvest losses and harvest costs. In addition, profitability analysis of the modern POT and farmers' practice is also presented in Table 6, wherein the deployed POT generated higher gross income ranges from 96,644 pesos to 105,432 pesos, compared to farmers' practice of 83,620 pesos. It also generates a higher profitability ranging from 40,632 pesos to 44,844 pesos, compared to farmers' practice with only 19,266 pesos. Overall, the modern package of technology evaluated in the farmer's field not only guarantee higher yield and income, but also reduce production costs. So this indicates its potential to increase the production and profitability of rice farmers in the rain-fed areas of Ilocos region. In conclusion, the use of high-quality seeds can provide at least 10% increase in yield according to the pallet check system. Mechanization, such as the use of transplanter and harvester, enabled efficiency in crop establishment and harvesting. Next is providing the required fertilizer inputs using the right element, amount, and time of application, along with other crop management practices, can achieve the target yield but reduce production costs. And along with other crop management strategies, such as water and pest management, the achieved outcome in the rain-fed areas can be sustained by using the package of technologies. Maximum benefits were achieved with the complementation of the different technologies. So that ends my presentation. Thank you very much for listening.
Thank you, Mr. Andres. So now, before we proceed with the question and answer, so may we remind our participants in the Facebook and YouTube to check the link of the attendance being flashed on the screen. So makikita nyo po doon sa may baba, may nagpa-flash na link. So yan po ang ating attendance for day 2. So please type in the link in your browser. So now, moving on sa ating question and answer, may I request Mr. Melvin Andres to be on stage and our three panel of judges. Okay, so welcome to our judges, Sir Francis, Miss Anne, and Sir Joseph, Engineer Joseph. So who wants to throw the first question?
Hi, good morning.
Yes, ma'am.
Okay, I will give the first question. Um, based on the cost analysis, so the most profitable combination was that for the POT with 6 tons per hectare target yield, right? That has the highest profit among the three. Um, then would it would it be safe to say that uh, targeting beyond the 6 tons per hectare wouldn't be as profitable? Say the farmer aims something higher than six. I'm just curious about that. Thank you.
Yes po. Good morning, ma'am. Good morning, everyone. Thank you, ma'am, for that question. So, based on our result from our field trials last 2021 wet season, so it reveals that the most profitable is the 6-ton yield target. However, in recommending our technology, our modern POT to farmers, we can give them the option because in increasing the yield targets, they could also we could also increase their cost of production, especially on the fertilizer inputs. Kasi kapag nagtataas po ng, can I speak po in Tagalog to more, uh, kasi
Yes, sir.
nagtataas po sa pagtataas po ng yield targets, tumataas rin po yung fertilization in farmers. And with our study, so kung ganito yung ilalagay niyang fertilizer, it could give you that yield levels. However, if the farmer has the capability to provide more fertilizer, so initial result pa lang naman po ito ng project namin. So therefore, we can also validate yung nutrient efficiency and in other areas, it is not applicable depende rin po sa location specificity. So maybe in other areas po, yung increasing the amount of fertilizer applied to our rice crops following the other technologies that package po sa ating modern POT, it could possibly increase their yield and profitability.
Okay, thank you.
Okay. Do you have follow-up question, Miss Anne? Or
Ano lang, regarding that, because you mentioned that, di ba, ano siya, yield-based fertilizer recommendation. That's
Yeah.
what's included in the POT. Naisip ko lang, kasi why is it that at, it's more profitable at 6 tons target than at 7 tons? Considering the fertilizer applied was also adjusted for the 7-ton target. Ayun, yun lang yung na-curious ako na even though you adjust the fertilizer as you increase the yield target, mas mataas pa rin yung profitability at 6 tons per hectare. So parang baka if they try to target 7 tons per hectare, mas mababa yung profitability nila. So baka mas maganda mag-stick na lang kami sa yield target na 6. So yun, yung mga ganong questions. Thank you.
Yes po, ma'am. Because our study focuses on inbred seeds po. So
Yeah.
therefore, the result will also be used by the farmers using inbreds. And we also looking into details po on what happened to our recommendation, particularly on the genetics of the variety we use, and including yung recommendation kung ano ba yung nangyari. At yun po yung nakita namin. Hindi po kasi kami nag-focus on our study in the nutrient efficiency or sa uptake ng nutrient. And at some point uh, during the implementation of the field trials, naka mas naging susceptible, bali nag-peak po kasi yung yield natin at 6 ton at bumaba na sa 7 ton. And we also correlate it with the stresses happens or affecting our rice crops, which possibly yung 7 ton yield target na nalagyan natin ng fertilizer application is naging more affected by those stresses.
Okay. Thank you.
Thank you po.
Okay. So,
I have
sino pa
some
po?
questions po. Um, Doon sa materials and method mo, ah, basically ang nagbabari lang is yung MOWET recommendation or yung target, tama ba? The rest ay the same doon sa lahat ng sites?
Yes sir, except po dun sa farmer's practice. So, bali yung treatment po namin is the whole package of technology with the varying nutrient management kasi yun po yung very critical na tinitingnan, particularly po these dates that mataas na masyado yung fertilizer cost po natin, sir.
Mm. Tapos doon sa sa land preparation, the same siya except that well level field yung lahat ng treatment. Paano mo nasabing well level field? Anong ginamit niyo na na
In
measure?
Yes po, sir. So in following po sa palay check system and in using the mechanical transplanter, it should also follows po yung appropriate na land preparation, particularly po dun sa, hindi ko po na-mention, dun sa shallow rotation para maging suited po, maging efficient yung mechanical transplanter po during the crop establishment. And by that time that the field was prepared, we make sure to follow the recommendation from the ballot check system to ensure na maganda po yung water management, nutrient management, and other pest management kagaya po ng control ng kuhol at the same time po sa weed infestation.
Okay, tapos do'n sa water management nakalagay mo is AWD, but you are in rain-fed lowland. Ito ba ay wet season mo ginawa?
Yes po, sir.
Okay, nandito pala. Kasi parang medyo mahirap 'yun
Yes.
gawin kapag rain-fed. 'Yun lang. Siguro with that, kasi ang sa sa experiment mo actually ang vinary mo lang talaga is yung fertilizer recommendation or the nutrient management. Pero siguro a comment lang ito dun sa title, ang title mo kasi Enhancing Rice Productivity in Rain-Fed Lowland Using Modern Production Technologies. Medyo pa siya, ano bang tamang term? Baka medyo malaki yung scope niya. Siguro mas recommendation lang para mas direct yung title. Pwede mo siyang gawing mas direct doon sa kung ano ba talaga yung objective ng study and ano yung result. Ayun. So pero in general, I like your poster kasi sa poster pa lang kahit kasi dapat gano'n ang poster, 'di ba? It can speak for itself. And nakita ko na dito yung gusto kong malaman. Salamat, Melvin.
Thank you very
Thank
much.
you, Sir Joseph. Si Sir Franz, would you have any questions to our first presenter?
Hi, good morning. Can you hear me?
Good morning,
Yes,
sir.
sir. Loud and clear.
Hi. Ayan. Thank you, Melvin, for the presentation. It was also presented, no? I have a question lang in terms of, can you just quickly run through the differences in terms of farming practices? Because I'm really curious with this, what are the various varying practices in terms of seed? Is it the same in those six sites in terms of the IPM? Because you have a lot of components or considerations to take, and I'm very much curious how and what are the varying practices, no? Especially in terms of using the mechanization part, kasi that's one of the things that you considered attributed in the good increase of cost or production. So, paano yung farming practice ng iba? Were they originally using mechanization or not? And in terms of variety, magkakaiba rin ba sila? Can you just quickly run through with that? Thank
Yes.
you.
Thank you, sir. For the farming practices po in the modern package technology, we make sure po that all those mentioned POT was implemented in six sites. So, yung project sites po namin kasi is in three neighboring barangays in the city of Batak. So, we manage that setups with the help of our farmers in terms of the variety. So sa lahat po ng six sites, iisa po yung variety na ginamit. Pati rin po yung mechanization. We also use or uniformly implement yung thorough land preparation, including po yung crop establishment using the mechanical transplanter. And yung fertilizer application, same rin po. Pero yung nakalagay po kanina sa poster ko, yung fertilizer application vary from one site to another based po dun sa result ng analysis na ginawa po namin sa MOET. Kasi yung MOET application po, yung -1 element technique with the help of the MOET app, generates a specific fertilizer recommendation for a particular location. Aside from that, sir, for the water management, we make sure to provide uh, we applied supplemental irrigation whenever yung uh, insufficiency ng rainfall. So in terms sa farmers practice po sir, dun po nagbabari kasi yung farmers practice po namin, we really don't manage po yung farmers practice para mawala po talaga yung bias. We just document yung rice field adjacent to our field setup. So from the time of the establishment or sowing up to the time of harvesting para makuha talaga yung all detailed information that are necessary to our project.
Okay.
Okay, thank you very much. I just asked kasi I'm curious about the replication, no? I mean, in terms of the social aspect, in terms of how would farmers actually replicate when it comes to using the organization or the trailer part, if they have it or not. A last question, sorry. In terms of
Yes.
the pest management, what were the pest management that you have applied during your experiment? I'm really curious also on that.
Yes, sir. In terms of the pest management, sir, we use a holistic approach. So, naggamit po kami ng pre-emergence herbicide on areas that has dominant with species. And also, nagkaroon po kami ng weekly monitoring ng insect pests and diseases to uh, provide or to have a timely approach in the application of pest management strategies such as for example sir on insect pests kapag during our observation na weekly po in all sites kapag nakita po namin na tumaas within the threshold level of a particular pest doon po kami gumagawa ng hakbang to control that specific pest that arises po.
Okay. Thank you, Sir Melvin. Thank you, Sir Franz. So, is
Thank
there
you very much.
any question, follow-up question? So, okay na tayo, mga sir, mga ma'am. So, kung wala na, so we still have 2 minutes sa ating Q&A. So perhaps we can uh, check one question from the Facebook. Meron po ba tayong question from the Facebook? So ito from Mr. Jose Bobby Manguera. So ang question niya, Sir Melvin, is it more profitable to just stick to the 6 tons per hectare applying the recommended or calibrated rate of fertilizer than targeting the 7 ton per hectare where more or 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 additional fertilizer is required, which will only produce not much? It does not necessarily mean that applying more fertilizer will result higher yield. The law of diminishing return may occur. Just an opinion. Thanks. So, Sir Melvin, would you respond to that question or comment?
Yes po, sir. Uh, Hello, Sir Bobby. I believe po that based on our result of our study that it is more profitable to use the 6 ton, 5 to 6 ton. Kasi bakit ko po sinabing 5 to 6 ton yung nutrient management for 5 to 6 ton yield target? This is because it depends po dun sa capacity ni farmer to buy fertilizer. Kasi alam naman po natin na mataas na ngayon yung fertilizer cost. Therefore, merong option yung farmer kung ano yung capacity niya or kung ano yung kaya niyang ibili. So kung hanggang 5 lang yung kaya niyang bilhin, so it's good kasi it could also mas mataas pa. Pwedeng mas mataas sa 5 tons pa rin yung pwede niyang anihin. Pero kapag meron siyang available, mas kaya niyang bumili ng additional fertilizer for the 6 ton yield target, it could be better. So
Okay.
that's my answer.
Okay, thank you, Sir Melvin. So that ends our Q&A for our first poster. So thank you, Sir Melvin. Thank you to our panel of judges. So balik po muna kayo sa ating backstage. So moving on to our second poster. Okay, thank you, Sir Melvin. So moving to our next poster. It's about enhancing, sorry. Second poster is about mycosis of resulting neonates of true armyworm, Mytimna separata Walker, eggs due to entomopathogenic fungi. This will be presented by Miss Melissa P. Montecalvo of the National Crop Protection Center of the UPLB College Laguna. Together in this paper are Miss Marcela M. Navasero, Mr. Mario Navasero, Miss Janren Sara Macaraig, and Mr. Jose Marie Navasero. So please welcome Miss Melissa P. Montecalvo.
Lepidoptera insect pests like armyworms are key pests in agricultural production. Their population is usually managed below threshold level using insecticide. However, a single control measure is insufficient to provide a sustainable pest management. Hence, our team explores the potential of entomopathogenic fungi as biological control agents. We conducted a research to determine the susceptibility of Metimna separata Walker eggs to this beneficial fungi. I am Melissa Montecalvo and the rest of the team are scientist Marcela Navasero, scientist Mario Navasero, Janren Sara Macaraig, and Jose Marie Navasero. We belong to the Biological Control Research Team of the National Crop Protection Center under the College of Agriculture and Food Science of the University of the Philippines, Los Baños. Agricultural pests like armyworms affect productivity of crops. This is true with the true armyworm, which is the target pest in our study. Metimna separata is called true armyworm. This is also known in several common names. This polyphagous pest infests 33 plant species, including corn, sorghum, and rice, causing massive defoliation and panicle damage. It has been reported in Asia and Australian continents with confirmed outbreaks in various countries. This lepidopteran insect pest and along with other insect pests are primarily managed through insecticide application. To reduce reliance to pesticides, there is a need to explore a safer, sustainable, and more environment-friendly means to control insect pests. Integrated Pest Management, or IPM, encourages the use of available and practical crop protection solutions such as pest monitoring, cultural control, physical control, biological control including microbials and natural enemies, and chemical control to prevent pest damage and protect natural enemies. An eco-friendly means to manage pest concerns is the use of biological control. Armyworms are effectively controlled by entomopathogens, such as nucleopolyhedroviruses, protozoa, and nematodes. Among these entomopathogenic fungi are promising biological control agents against transboundary pests due to their global distribution, safety, and environment friendliness. Microbial control utilizes fungi to lower the insect population and damage. Common EPF tested are Bavaria, Isaria, Ursitella, and Metarhizium. These beneficial fungi cause infection to their host by initiating conidial attachment and penetration to the insect cuticle, resulting to insect death. They subsist as saprophytes in organic matter and may also dwell as endophytes of several plants, making them valuable in pest management. Considering the potential of entomopathogenic fungi, this research work aimed to assess the effect of entomopathogenic fungi on true armyworm eggs and, of course, the resulting neonates. The following entomopathogenic fungi were evaluated in this research. Bavaria bassiana and Metarhizium manisople were revived from the culture collection, while Metarhizium rulei was isolated from Spodoptera exigua, or onion armyworm. These entomopathogenic fungi have been tested in our laboratory against other Lepidopteran species. What we did to obtain our research objective is summarized in this slide. Laboratory rearing of true armyworm was conducted at NCPC. Adults of Metimna separata were collected in the corn experimental field. Male and female adults were paired and mated in mylar cages. Egg masses were harvested from the cages and placed in rearing pans with fresh corn leaves. Larvae were then fed with fresh corn leaves daily. Laboratory bioassays of entomopathogenic fungi against the true armyworm eggs were conducted. Egg masses that were freshly laid were counted under dissecting microscope. Egg masses with approximately 60 to 80 eggs were used in the experiment. Egg masses were mist sprayed with 1 × 10⁹ conidia per ml of each entomopathogenic fungi, while 0.1% Twin80 solution was sprayed in the control setup. Each setup was replicated 7 times and incubated in the sterile Petri plate with moistened cotton at ambient condition. Hatchability of eggs was counted daily. Neonates emerging from these egg masses were transferred to a sterile Petri plate, fed with fresh corn leaves daily, and observed for mummification. Laboratory bioassays were arranged in complete randomized design, and the virulence of the entomopathogenic fungi was compared by analysis of variance using Tukey's honest significant difference test. The succeeding slides will highlight the significant findings of this research, such that the entomopathogenic fungi had no ovicidal activity, but the resulting neonates succumbed to fungal infection. The three EPF, namely Bavaria bassiana, Metarhizium manisople, and Metarhizium rilei, did not significantly affect the hatchability of true armyworm eggs, as seen in Figure 2. 13 to 23% hatchability was recorded in EPF-treated egg masses in comparison with 24% hatchability in control. The eggs of true armyworm were not susceptible to the 3 entomopathogenic fungi, and this conforms to our previous findings that Metarhizium rilei isolate did not have ovicidal activity against onion armyworm. However, this contradicts to our results that Bavaria bassiana and Metarhizium manisople slightly affected hatchability of fall armyworm eggs. Differences in the results suggest that egg mortalities depend on the conidial concentration and morphology of the eggs, which are covered with the hydrophobic scales that repel moisture needed for conidial germination. This figure shows the proportion of survivorship of true armyworm neonates hatched from treated eggs. Even though the three entomopathogenic fungi tested did not have ovicidal activity, a significant number of the resulting neonates from the fungal treated egg masses succumbed to fungal infection at larval stage. About 65% of these neonates mycosed mostly at larval stage as indicated by the blue bars, and very few emerged into adults as shown by the proportion of yellow bars, which is about 16%. Meanwhile, 64% in control completed their life cycle and successfully emerged into adults. Our present finding conforms with our results on bioassays on onion armyworm and fall armyworm exposed to Metarhizium relayi, wherein larval instars hatched from the treated egg masses had fungal infection. Similarly, the larval instars of cotton leaf worm emerging from the treated egg mass succumbed to Metarhizium relayi infection, suggesting contamination of the first larval instar with the fungus in the treated egg mass upon feeding in the chorions, or may be infected by the germinating fungus in the egg integument. In our previous research, we also demonstrated the effect of entomopathogenic fungi to various biological stages of true armyworm. Among these entomopathogenic fungi, Metarhizium relayi caused the highest lethal infection to first to fifth larval instars, while Bovaria bassiana inflicted significant mortality in sixth larval instar. Metarhizium ensople and Metarhizium relayi significantly reduced adult emergence in prepupa. Metarhizium anisople, on the other hand, caused significant reduction in adult emergence in treated pupa. To summarize our findings, we can say that true armyworm eggs are not susceptible to entomopathogenic fungi. Even though no ovicidal activity was observed, results suggest that entomopathogenic fungi caused little infection, particularly to larval instars. This implies that mycosis of true armyworm larvae will occur if neonates will be exposed to entomopathogenic fungi upon hatching. Hence, the fungal treatment should target the early life stages of true armyworm to prevent severe infestation and damage. Future studies will focus on upscaling this entomopathogenic fungi. This project was made possible by the funding grant from the Department of Agriculture, Bureau of Agricultural Research. We also acknowledge the support from the host institution, University of the Philippines, Los Baños, and National Crop Protection Center. Likewise, we are thankful for the assistance provided by our project staff. It is our pleasure to present this paper in this conference. Thank you for your attention.
Thank you, Miss Melissa Montecalvo. So that is our second poster. So may we request our panel of judges to be on stage? Okay. So who wants to ask the first question?
Hi, I will go ahead again.
Okay. Ladies
Okay,
first. Ladies first.
okay, okay.
Yes, ma'am. Please proceed.
Uh, okay. Hi, good morning, Isa. Um, I just want to ask, because you mentioned that it's it seems that it is not so effective against the eggs, but more effective on the larval stage, right? Um, I'm just curious how, in terms of applying it or application of this, anong, paano ba? How different would it be to use it against the eggs and against the larva? Mas mahirap ba or mas mabilis if sa larva siya at larval stage i-apply, or at, during the sa egg masses lang? Ayun. Thank you.
Hi, good morning, everyone. Thank you for that question, and that is actually a good ask. The eggs are not susceptible. That is due to the what do you call this? The hydrophobic scales that are called because the larval instars or the larvae are inside the hydrophobic scales. Therefore, it serves as a barrier. And aside from that, there is window for fungal infection to occur. But as we all know, these larval instars are hatched from these eggs. And based on the monitoring in the field, these true armyworm lay their eggs in the leaf sheath. Therefore, if we can spray this entomopathogenic fungi to corn or to any other crops, then upon hatching, these larval instars, or we call this neonates, would be contaminated with this fungal inoculum, and therefore they would still succumb to fungal infection. Yes, it is not the eggs are not susceptible, but the larval instars are very susceptible. Timing is very important.
Mhm. Yeah. Okay. Thank
Okay.
you.
Okay, thank you, Miss Anne. So no follow-up question for
Oh,
Miss
no, no.
Melissa. Okay. So how about Sir Franz and Sir Engineer Joseph?
Yes, ma'am. Hi, Melissa. Meron na bang ano, available in the market na metarhizium? Para kasing narinig ko sa ano, ah, kung meron siyang product na available.
Okay. In the Philippines, I'm not so sure, but abroad there are products already developed with AI of Metavision and Bavaria. But in the Philippines, farmers can still apply Metabrizum and Bavaria and other entomopathogenic fungi because our regional crop protection centers mass produce this entomopathogenic fungi.
Yes, yes. Kasi, meron akong narinig from them sa RCPC nga galing. Kasi isa ako sa ano, naapektuhan ng fall armyworm sa corn. Kaya parang this is a good study na shinare nyo. So, wala na naman akong ano pa, ma-question.
Okay.
Hi.
Thank you, Sir Joseph.
Hello.
Yes, Sir Franz.
Hi. Good morning, Miss Melissa. That was very informative and very ano no timely sa panahon ngayon na we really need to focus on environmental friendly um, in terms of pest management talagang. And I just would like to know, relevant to Sir Joseph's no, in terms of cost, if ever if this will be used by our farmers, will it be accessible to our farmers in terms of buying or using it as a biological control in terms of their pest management?
Mhm. That's a very good point, sir. And of course, we would like to share this technology to our farmers. As I have mentioned earlier, these are being mass produced by the regional crop protection centers, and I guess these are being offered for free. And they would just need to request from RCPC to have this isolate. But I'm not yet so sure if they have the Metavisium relay isolate.
All right, thank you for that information. Then I just a last question now. I'm just curious in terms of the application of the fungi in the eggs. Um, Tama no, you only have one in terms of volume, parang isa lang. How were you able to determine that? And I'm just curious, will increase in the volume of the fungi in the growth?
Sir, excuse me. Are you asking our laboratory assay about the concentration or the volume that was sprayed?
Okay, yeah, concentration. Yeah.
Mhm.
No,
Okay.
or perhaps both the concentration and the volume that you used.
Mhm.
Is it
Okay.
the same for all, and would increase in volume or concentration affect in the test?
Mhm. Uh, at some parts, sir, I think you are muted. I missed the last part or your question, sir.
Is it okay now? Okay na
Yes, yes,
ngayon.
sir. Yes, sir.
Yes, yes, sir.
Of concentration and volume as well. Is it true to all? I mean, is it the same for all? And second, would increase in concentration or volume of controlling that test? I'm just curious on that.
Mhm. Ah, that's a good question, sir. In the case of volume, we prepared the similar volume for all the entomopathogenic fungi. And for the concentration, we prepared one that's 10 to the 9 conidia per ml. One, two, three. That's 100 billion spores per ml. And it's equal among the treated eggs. And regarding the concentration, yes, it would affect the little infection, or we call that epizootics, that will be caused by a pathogenic fungi. Because as we have learned from our previous experiments, that spraying or applying higher concentration of EPF would entail faster mortality and as well as higher mortality to larval instars.
Okay. So, okay na daw si Sir Franz. So, we still have 7 minutes for the Q&A. So, can we have some questions from the... Oh, si
Um,
Sir Joseph, may
I
follow-up
forget the
question.
question. Ma'am, pag na-spray ba siya, halimbawa one cropping season,
Mhm.
ah, and then hindi ka naman nagtatanggal ng biomass, andun lang yung fungi, nandun na siya sa field, or you need to spray every season or every crop?
Mhm. Okay. That's a good point, sir. And I think that would be the concern of our farmers. Actually, entomopathogenic fungi are naturally occurring in our agroecosystem, but we have to enhance their population. Therefore, we have to apply them based on the monitoring, based on pest monitoring, sir. Right now, we are uh, treating at 7 to 10, depending on the monitoring, or at 12 days after planting, that's in corn, up to 7 sprays, 4 to 7 sprays.
Okay. Okay
And
na
of
ba yun,
course,
Sir
we will
Engineer?
have to, uh,
Yes, ma'am. Please
may I
proceed.
also add, yes,
Yes, ma'am.
sometimes um, we skip, it's not weekly, or for example, it's not at 7 days interval, depending on the environmental condition. And of course, we have to really apply it again because we have uh, climate change, or maybe varying temperatures, varying environmental conditions that would really affect the fungal infection.
Okay. So, okay na ba tayo mga judges? So, may we have the questions from the Facebook. So, this one is from Alkin, Sir Alkin Uy. How effective is your method of controlling army worms as compared to push-pull technology, which is more sustainable and much practical to adapt by our farmers, I think. Miss Melissa?
That's a difficult question because we did not set up a comparative field experiment for that. But what I can say, because I'm working on entomopathogenic fungi, therefore I would say that it's really effective. And of course, we can integrate it in the intercropping strategy because we are not targeting only one pest here, but we are more concerned of the other pest population in the field.
Okay, thank you, Miss Melissa. So, we have question here. So, basahin ko lang ano. Uh, this is from Sir Virgilio Jacosalem. So, army worm attacks is not seasonal. It appears every 2 to 3 years and maybe 5 to 6 years. How do you control an army worm already attacking your field when you wake up? So that's the question.
Mhm. Okay. Then actually, in our field here at CES in UPLB, we have planting seasons. We just rest our field for I guess 1 month or 2 months and then plant again. But during those seasons, we still have infestation. In his question that if we have this number of army worms, then I guess I would suggest pest monitoring should be done.
Okay. Okay na ba, Miss Melissa, yung iyong ano? Parang nakakat ka yata.
Ako po.
Okay?
Hello?
Oo. Okay. So we still have 3 minutes. So can we have another question? So another question. In the field testing, farmers do apply fungicides. Are there tests conducted if the entomopathogenic fungi are affected by this commonly used fungicide in corn, for example?
Okay, again, that is a practical question. In the Philippines, I guess there is no local data that entomopathogenic fungi are susceptible to fungicides being sprayed in the corn fields or in other crops. But that is what I am doing now. I am conducting in vitro testing of these fungicides to determine if this entomopathogenic fungi, the Beauveria bassiana, Metarhizium manisople, as well as the Metarhizium relay, if they are sensitive to the fungicides being sprayed to corn against corn diseases. But of course, if we have data in Philippines, then we can say that oops, let's not spray fungicides at this moment because we sprayed entomopathogenic fungi. But in abroad, they also have they also have the data on the sensitivity of this entomopathogenic fungi.
Okay. So thank you. So maybe this is the last question for this poster. This one is from Miss Leia Cortezano. If I applied it on the field, maapektuhan ba nito yung ibang insect like other beneficial insect?
Okay. Mm. In the case of Metarhizium relay, it has a narrow host range. There and there are also studies saying that this entomopathogenic fungus is does not affect the non-target organisms or the natural enemies. In our case, I don't have a local data right now, but in our field experiment here at UPLB, we have not yet tried what do you call this? Combining entomopathogenic fungi and other natural enemies, just like earwigs. We have single treatments of this, and that would be our future plans to really determine if these are compatible, if this can be applied at the same time.
Okay. So that's it. So thank you, Miss Melissa, for your presentation. And thank you to our judges. So our next paper is entitled Efficacy of Various Substrates on the Growth and Yield Performance of Gray Oyster Mushroom. This paper is from the Jose Rizal Memorial State University, authored by Dr. Lucrecia A. Pontonillas. together with Miss Mary Grace Pizon and Miss Jeneline T. Tata and Sir Noel G. Sales.
Pleasant day, everyone. Our study is on the efficacy of agricultural substrates on the growth and yield performance of gray oyster mushroom, or the scientifically known Pleurotus austriatus. I am Lucrecia Puntillas. Together with me are Mary Grace Pizon, Jeneline Taata, and Noel G. Sales. We are from the College of Agriculture and Forestry of Rizal Memorial State University, Katipunan campus. The oyster mushroom is one of the most important mushrooms, and it is commercially cultivated for food. And its world production is rapidly increasing day by day. Alternative substrates need to be studied in order to determine their suitability for use by both commercial and small-scale farmers in mushroom production. Mushroom cultivation is also a viable and attractive activity for both rural farmers and pre-urban dwellers. The objectives of the study is to produce mushrooms and evaluate the growth and yield of in different substrates, and also to evaluate the return of investment. The study was conducted at Rizal Memorial State University, Katipunan campus, Katipunan, Zamboanga del Norte, on April to July 2021. Completely randomized design was used with 6 treatments. Each treatment have 10 samples and replicated 3 times with a total of 30 protein bags. These are the treatments. We have T0, sawdust, T1, corn husk, T2, rice straw, T3, dried banana leaves, the T4 is the coconut leaves, and then the T5 is the bamboo leaves. So the substrates were prepared. Each of the substrate were chopped into 1 to 4 inches long. Substrate were separately soaked in water within 12 hours rather. After 12 hours of soaking, the materials were transferred to a chamber to remove the excess water. It was mixed with rice bran, limestone, and brown sugar with a ratio of 78 agricultural waste, 20% rice bran, 1% powdered limestone, and 1% brown sugar, which was done manually using shovel or paddle. Water was added to each substrate. Bagging was done in a polypropylene bag but with a dimension of 6 by 2 by 12 by 0.03. Pasteurization was done. Inoculation was done after cooling all of the protein bags. All materials were prepared first, like the alcohol and the other materials. So incubation was also done. All bags were transferred to the room and observed there is contamination. The observation was done daily on the mycelial growth and make sure that the mycelia growth was covered with 90 to 100 of the fruiting bag before transferring it to the growing area. Harvesting was done early in the morning or late in the afternoon. So this is now the results of the study. The figure 1 shows the length of mycelium at 14 and 28 days after inoculation. So the mycelial growth was relatively higher on bamboo leaves than on other treatments. The four treatments, rice straw, dried coconut leaves, dried banana leaves, and sawdust, were found to be comparable to bamboo leaves as to the length of mycelium at 28 days of incubation, as according to Chukia's HSP. Corn husk got the shortest length of mycelium at 14 and 28 days. All treatments except corn husk seem suitable substrate used in terms of mycelium growth. The observable difference among the treatments and the length of mycelia may be due to the composition of substrates, as according to Owagwo et al. 2020. According also to Mondi et al. 2010. The next figure shows now the length of the mushrooms type. It was observed in the first flushing that corn has obtained the highest length of the stipe, and it was comparable to rice straw, coconut, and bamboo leaves, while the shortest length was recorded in sawdust and statistically similar to banana leaves. Also, it was found out that the trend in first flushing was almost similar to the fifth flushing, considering corn has got a superior length of a stipe in all flushing. The figure 3 shows the diameter of mushroom cup after the first flushing using agricultural waste. This study revealed that in first flushing, bamboo leaves was found superior in terms of diameter, but it was comparable in other treatments except in the control. In the second flushing, the diameter of mushroom declined in bamboo leaves, but banana leaves increased in diameter, and it was similar to other treatments except in bamboo leaves. While the third flushing, corn has arrived at a superior diameter, but it was comparable to other treatments except in rice straw, coconut leaves, and bamboo leaves. These results were almost the same to that of the fifth flushing. The next figure shows now the total yield of mushroom after all flushing. The total yield of mushrooms after all flushing shows that the corn husk and rice straw were significantly different at 1% level from other treatments, and they were all also superior in terms of yield. A high yield of mushrooms in rice straw is due to easier nutrient solubilization in cellulosic substance once they start to degrade. This is according to Ponmoroagan et al. 2007. And the last figure is on the return of investment. The highest percentage of the return on investment was attained by corn husk, and it was almost similar to rice straw. However, the lowest percentage of return on investment was obtained by coconut leaves. This study declared that both corn husk and rice straw were the best substitutes This study declared that both corn husk and rice straw were the best substitute in sawdust, or can be an alternative in the cultivation of raw oyster mushroom, considering corn husk and rice straw got the highest return on investment. So in conclusion, corn husk and rice straw were suitable for use in oyster mushroom production. The researchers recommend using corn husk and rice straw, or in combination with corn husk plus rice straw, and other agricultural waste that can be found and abundant resources in the locality as an alternative sawdust. Thank you very much for listening.
Okay, so there you have it, our third poster paper presentation. So since Dr. Pontillas is not around, so she will be represented by her colleague, Miss Mary Grace Pison. So welcome, ma'am. And may we have our panel of judges to ask questions.
Good
Yeah.
morning, everyone. I'm Mary Grace Pizon in behalf of Dr. Lucrecia Puntillas because she is in emergency right now.
Okay. So, sino pong nais na maunang magtanong sa pinresent nilang paper?
Sige, ako naman.
Okay. Si Sir Franz naman daw.
Sige po, Doc. So, good morning, Miss Mary Grace. So,
Good
ano,
morning,
again,
sir.
no? Okay. Interest the use of agricultural waste as we help in protecting and conserving. I would just like to know, in terms of determining the ROI, how were you able to compute that, knowing the fact that these are agricultural waste? What were the means of costing that you have done to ensure that, ano, syempre, no, na-compute natin siya ng maayos? Kasi I believe if it is waste, it's most likely free. But then again, if it will be commercialized, um, that in terms of determining the ROI. So how did you do it? Thank you.
In computing ROI, sir, since the dried coconut leaves is already available, so we didn't buy that one. We just compute the limestone, the bags that we use, yung mga substrate po sir, hindi na po namin binibili. Yun lang pong mga hello,
Yes, ma'am.
yun lang yun lang pong mga binibili namin yung mga polyethylene at saka ay, yung bags, yung rings, yung yung so, rubbing alcohol, needle, rubber band, cotton, PVC pipe. Yun lang po yung inaano namin sa pagkuha ng ROI namin. Yung
Oh,
mina-minus namin.
oh,
Lahat ng gastos.
okay.
Thank you for that. But in terms of the sawdust, which is the control, were costs given? This would like to
Ah,
clarify.
yes sir. Binibigay lang po sa amin dito sa Mindanao. Available lang po,
Okay.
kaya hindi na po namin inaano.
So even in sawdust, hindi na consider.
Yes,
All right.
sir.
Thank you. Thank you.
Okay. Thank you, Sir Franz. So may question po ba
Hello?
si Ma'am Ann? Yes, ma'am.
Oo. Ano, in relation din dun sa first question ni Sir Francis, kasi mukhang ang sinama sa computation ng cost ay yung, sabi mo nga, yung mga binibili, which I assume is the same for all treatments. So, ang magbabago lang ay kung soda siya, kung husk, kung straw.
Yes,
So,
ma'am. Yun lang po,
oo,
ma'am.
yung mga ganon. So, kung walang
Substrate po na ginagamit.
yes po. So, kung wala pong presyo yung substrate na ginamit natin, paano natin na-differentiate? I mean, how did we arrive na kung magkakaiba yung cost nila? Or kung yung ROI ba natin ay parang same lang silang lahat ng cost, tapos nagbago lang kung saan mas pinakamalaki yung naging profit based dun sa harvest ng mushroom. Tama ba? Ganun na lang. Kasi mukhang pag ganun, pare-parehas sila ng costing. Uniform. Tapos libre yung mga substrate.
Yes. Yes, ma'am. Kasi ang inaano lang po namin, ma'am, is yung locally available lang po sa amin.
Mhm.
Na hindi na magkakos ng mga substrate.
Okay. So in areas say na binibili ang rice straw, for example lang ha, hindi ko naman sinasabi binibili siya in all areas. Pero in cases, kasi di ba sa results nyo, siya yung parang maganda, di ba? Yung
Yes, ma'am.
rice straw and the corn husk. Say yung rice straw or corn or yung husk ay binibili in an area. So dadagdag yun sa costing if ever
Yes, ma'am. Dadagdag yun. If bibilhin po.
oo, oo.
Pero
Okay.
dito po kasi sa amin, ma'am, is sinusunog lang. Kaya, yun.
Oo. Yun nga. So magandang magkaroon ng gamit itong mga waste products natin na agriculture. Sige. Thank you.
Okay.
Thank you, ma'am.
Thank you, Miss Anne. Si Engineer Joseph,
May
would you have may follow-up question lang daw si Sir Franz.
Apo. We are asking lang po ma'am kasi ano syempre, in terms of computing for ROI kasi, it will be good to know the costing para mas malaman in the future in terms of replication. So I think this one is very specific to your area. It's ano, it's no cost at all. So yun yung magandang nakuha kong point na it will be site specific area. But for future references, it'd be good to have cost then para lang in terms of replication, mas maano natin, malaman ano ba talaga yung pinaka-best in terms of using it, especially in terms of business aspect. Thank you.
Yes, sir. Thank you, sir.
Okay. Sir Engineer Joseph?
Good morning, Ma'am Mary Grace. Thank you sa presentation ni Ma'am kanina. Um, Actually, maganda itong study kasi sinubukan ninyo yung mga locally available biomass or yung mga considered as waste na like bamboo leaves, coconut leaves, tinatapon lang talaga yan. Although practice na naman yung sawdust or coconut sawdust
Todas.
and ano tawag dito? Rice straw na ginagamit talaga yan as for
Mushroom
mushroom
production.
production May question lang ako, siguro clarification. Sa treatment mo kasi nakalagay is 6 treatment times 10 samples per treatment tapos 3 replication. So dapat siya, hindi siya 30 fruity bags. So ano siya dapat, no? 6 times 10 times 3. Tama ba?
Si,
Kasi
bale
ano
by
lang yun.
CRD po yan, sir. So, 30, kaya po naging 30 per treatment. Kasi inano na po siya sa treatment, replication 1, replication 2, and replication 3. So, tag 10-10, kibali sa 30.
I think hindi tama yung computation. Kasi 6 treatment siya times 10 bags per treatment
Yes, sir.
times 3 replication pa or nandun na sa 10 bags ang 3 replication. So 60
Yung
siya dapat.
60
Anyway,
dapat, sir,
ano
kung sa
lang naman yan.
replication 1 lang po. Kung sa replication 1 lang po pag-uusapan. Pero ang inano po kasi namin dyan is CRD yan. So sa replication 1, so may isang treatment. So treatment 1, so yun na po yung total 10. Treatment 2, replication 2, replication 3. So nagiging 30 po. Kinombine po yung replication 1, replication 2, replication 3 na tag 10-10. So kaya naging 30.
Parang hindi ko gets. Anyway, so kasi very straightforward naman sana yung computation na 6 treatment times 10
Lagi,
bags
sir.
times
Mas
times
madali
3
po sana
replication.
kung ganyan po.
Di ba?
Mas madali po sana kung ginanyan po pagkwenta. So 60 times 3, ganyan na lang po sana. No, 60
Oo.
times,
So bakit
60 times
bakit nagkaroon lang ng 30 protein bags lang?
30 protein bags per treatment po, sir. Kasi meron po siyang replication 1, replication 2, at saka replication 3. So, total po,
Okay.
30, ginanon
Per
po yun.
treatment, 30
Yes, sir,
30
per
bags per
treatment.
treatment times 6 treatment. Okay. So
Uh,
that's 180 bags. Ano lang. So that's 30 bags per treatment.
per
Tama 'yon.
treatment, yes, sir.
Okay, okay. Aha. Siguro ano, 'yun lang naman. Sa ano kasi, sabi ko nga kanina, maganda yung study kasi kahit mababa yung result ng ibang mga biomass or we consider as waste, pinrove nyo na tumutubo ang mushroom doon. Um, ayun. So kasi very ano lang yan very common sa kahit saan sa atin. May
Yes, sir.
kawayan, may niyog, and mayroong mga uh, banana leaves. So, yun lang. Thank you, ma'am.
Thank you, sir.
Thank you, engineer, and
I
thank
have
you, Miss
last
Philippines.
question.
Yeah, yes, Sir Franz, you
Sorry.
may
I
proceed.
know this is not part of the research, but I'm not curious. I'm just curious. Were you able to taste the the mushrooms that you have produced? I think this is for your food consumption. I believe. Were you mentioned nasama sa research, but siguro perhaps something to consider were the differences in terms of taste with the substrates that you used. Kasi, syempre, diba, what you use could affect the taste, and this is for food consumption. O kung di man siya kasama sa research, were you able to taste it?
Yes, sir. Recommendation po. Pwede po yan sa recommendation, no? Yung
Okay,
taste
so yung
quality.
ano, yung ginawa nyo at the onset, hindi natin na taste pa rin. Sige. Thank you. But it's good research. Thank you.
Thank you, sir.
Okay, so next time titikman natin 'yon, Sir Franz, kung anong lasa talaga nung. Baka lasang ano pala 'yon, sodas ano, hindi joke lang po. So 'yon. So we still have 4 minutes. So we can have some questions from the Facebook. So, ma'am, ito po ang question from our Facebook participants. How about the growth parameters like weight of the mushroom in terms of yield in kilograms using different substrates? Ano po yung best substrate in terms of the yield per treatment?
In terms po sa yield, meron po sa, yung ano po, sir, yung rice straw at saka corn husk on different substrate. Ano best substrate? So, sa recommendation po namin, pwede pong i-combine kasi parehas naman silang maganda yung resulta, yung rice straw at saka corn husk. So, kung kaunti lang po yung rice straw or kaya corn husk, pwede po silang i-combine. Siguro,
Okay.
for follow-up
Okay.
study po.
Okay.
Pwede rin follow-up study.
Mm. So, yun yung ano. Pero ilang kilo ba ang nagiging yield? So, yun yung interest din nilang gustong malaman.
Ah.
Dun,
Yung by grams po, ay by kilogram ba to? By grams.
yes
So,
po.
yung
Yes.
mataas po, yung corn husk po, nasa almost 2.5 kilogram po. At saka
Okay.
nag-next yung rice straw
Okay.
na 2.2, and then yung T0, yung control po natin is ano lang po, 1.4 kilogram.
Okay. So, yon. So, thank you, ma'am. So, can we have the next question? So, this one is from Sir Ronald Alan Di Maano. His question is, what are the components of corn husk and rice straw that made it suitable for oyster mushroom production? Or so, yon, ma'am.
Ah, so based lang po sa ano ko sir, instinct ko sir is yung mushroom kasi tutubo yan pag mataas yung klase ng yung urea. Tapos sabi po kasi nila yung rice straw at saka siguro rice straw at saka yung corn husk mataas po yung uri ng klase ng urea. So kaya po mataas yung yield niya.
Mm, okay. So, yon, it's more of the urea daw, sabi ni Ma'am. Okay. So we can still have more questions. So this one is from Sir Felix Factor. Nawala yung question, sir.
Ba't yung kalidad?
Ah, nag So this one is from Miss Glenda Aaron. So give values for all substrate used to compare differences in cost of production. So parang na ano na yon, parang related din doon sa question kanina about the yield per treatment.
Also labor.
Okay. Ito naman from Miss Melicen Camayo. Also, labor will be different across substrate kasi mas mahirap po magbagging ng rice straw and corn husk compared sa soda. So, tama naman. So, siguro, yun din yung isang kailangan i-consider. Next, next question, still from Ma'am Kamayo. How many days ang decomposition ng corn husk and its portion with other ingredients like lime, sugar, and rice bran? Miss Mary
Ay,
Grace?
yes, ay yung ano po sir, yung corn husk po sir, pinartially decompose po muna namin, hindi yung bago. Tapos yung ingredients like lime, sugar, and rice bran, ina-add lang po namin yan during the mixture, the substrate. So inano po namin yung corn husk sa tubig, binabad ng 12 hours, tapos inilagay sa chamber para tutulo yung tubig. Tapos after that, medyo, medyo ano na sila, medyo hindi na basang-basa. So, may test kami na yung ano lang, yung thumb test na, na 60% ba yun? O 60% na, inano namin, ini-squeeze kung wala nang tutulo na tubig. So, pwede na yon i-ano, ibagin. Pero kung yung sobrang ano naman po, yung sobrang dry, sobrang dry talaga na sila. So, yung rice bran, hinalo, at saka yung sugar. Yung sugar is, inano muna namin sa tubig para maano po siya, para ano ba yun, matunaw. Kasi, binabasehan din po namin kasi yung sabi ko kanina, yung pag-squeeze namin kung hindi masyadong basang-basa. So, kaunti lang pong tubig kung basang-basa na siya or hindi kung basang-basa na siya, so konti lang po ang tubig. Tapos nilagyan namin ng lime. Tapos yun, binabag na namin agad after nung hinalo
Okay.
yung lime, sugar, at saka rice bran.
Opo, ma'am. So, it means 12 hours lang po yung decomposition. And for the,
I know,
uh,
yung pagbabad po
ilang,
sa tubig.
yeah,
Yung
yeah, yeah.
pagbabad po sa tubig is, ano lang po, mga almost 15 to 1 month po yung decomposition.
Okay.
Partially
So,
decomposed na mga, ano po.
so perhaps yung proportion siguro, Ma'am Kamayo, mag-message na lang po kayo sa kila Ma'am Mary Grace sa group po nila for the further details. So, yun
Pero
po,
po
wala na
sa
po
ano, okay
tayong.
po.
Yes, ma'am.
Pero po yung sa
Wala na.
substrate, okay sige po.
Sige, ma'am.
Pero yung, sige, pero yung iba po yung decomposition na process namin sa, ano sir, sa sodas. Kasi hinalo muna namin yung mga like limestone, uh, limestone, sugar, at saka rice bran, at saka bago namin dinicompose.
Okay. So, yung specific details po, perhaps yung ating pong nag-question na participant can directly communicate po sa inyong group sa JRMSU. Okay, so that's our third poster paper. So perhaps we can have some break, about 10 minutes break. So we will be back at exactly, ano bang oras na? 9:56. So we will be back at 10:06. So mag ano muna tayo, coffee, stretch, tapos mag snacks na rin kung meron po kayong snacks. So see you later for our fourth and fifth uh, poster presentation. Thank you.
We are Filipino by design. Our roots have attuned us in promoting agricultural sustainability through sheer Philippine ingenuity. We are driven to progress. Back in 1997, our group of less than 20 staff and field employees had to face financial limitations and market concerns where we had to prioritize funding only in select areas. Armed with only two products and constantly anxious over unguaranteed success, we faced industry giants coupled with an unpredictable and overcritical market. This is why reaching 25 years is not due to a stroke of luck. Our founders focus on their dreams to support the Filipino farmer set up his entrepreneurial goals for a sustainable livelihood. Our vision of a developed society is rooted in an agricultural system that thrives amidst calamities and global pandemics. Thus, we collaborate and cooperate with groups that share the same goal. New opportunities excite us. Every day, we discover new opportunities that expand our capacity for growth. In our earlier years, we founded Leeds Environmental Health Products Corporation and Leeds Animal Health Corporation, which are agriculture-related companies that cater to markets beyond rice and vegetable farming. Prime Stocks Chemical Corporation and Golden Prime Stocks Corporation focused on streamlining the production and selling of high-demand products. By our 20th year, we decided to serve different aspects of the farmer's value chain. We started Leeds Tech Corporation for agri-machinery, Leeds Agri-Ventures Corporation for the production of quality seeds, and Leeds International Corporation to address rice consumer demand. The year 2020 saw us reach unprecedented heights when we surpassed 2 billion pesos in sales. This encouraged us to widen our reach and tap into the real estate industry through Malveda Properties and Development Corporation, which is geared towards development programs for smart city living. We take civic duty seriously. We launched Leeds Diagnostics to give back to the communities that have supported us into the company we are today. We are excited to launch our medical missions and outreach programs that will be accessible to even the smallest farming communities anywhere in the country. From a small company initially overlooked by the industry and that barely hits their growth targets, we now have more than 300 employees serving over 1,000 agricultural dealers and distributors, which equip millions of Filipino farmers with the right tools and technology nationwide. With an experienced portfolio that covers multiple industries, we continue to expand the dream started by Filipinos for the Filipinos.
Okay, once again, welcome to our second day. And before we proceed, I would like to thank our sponsors of this Congress. We would like to thank Picard, Leads Agri, Hipra, Nature Tech, and Circa for supporting this Congress. Back to you, Doc Ronnie.
Thank you, Sermon. So we still have 2 minutes before we resume. So perhaps we can greet po muna yung ating mga kasama, ang ating mga participants. So good morning daw from Sir Edwin T. Okoy from WPU Aborlan, Palawan. Welcome, sir, and thank you for joining us. So from San Jose, Negros Oriental, welcome po and good morning kay Ma'am Evangeline, nawala, Evangeline Manuel. So, yon ma'am. And then, good morning din and thank you for joining us, Miss Janelle Redondo Buenaflor, watching from the City Agriculture Office. Dito lang, malapit lang, Calamba City, Laguna. Welcome po, ma'am. So, also from Sugar Regulatory Administration, si Ma'am Nes Manlapas Kasupanan. Welcome, ma'am, and good morning po. Si Sir Benji Lacque Valmorida also joining us, watching from Bukidnon sa Mindanao. Welcome, sir. And si Sir Jonan. And si Ma'am Cyril Advento from Pakil, Laguna. Member siya ng Sierra Madre chapter ng PAA Region 4A. Good morning din po sa ating kasamahan from DARFO 9 Research Division, si Ma'am Irene. Good morning din po and good morning Ma'am Rose. Thank you for joining us. So this one from Lanao, Kapatagan, Lanao del Norte from the LGU. Good morning po Ma'am Fe Enriquez. So last na po muna for now. So watching daw from Department of Agrarian Reform, Municipal Agrarian Reform Office, Municipality of Alyosan, Province of Cotabato. Yon, medyo malayo din. So perhaps we can resume our poster presentation. So can we have the fourth poster paper? So still from the Jose Rizal Memorial State University, our fourth poster paper is entitled Effects of Organic and Inorganic Rooting Hormones on the Propagation of Bourbon Rose. So this will be presented by Mr. Darwin J. Lahera. And together with him are Mr. Roberto Camanas Jr., Mr. Giovanni Elogsong, and Miss Evelyn P. Pusod.
Good day, everyone. Our study is titled Effects of Organic and Inorganic Rooting Hormones on the Propagation of Bourbon Rose, or scientifically known as Rosa bourboniana. I am Mr. Darwin J. Lahera. Together with me are Mr. Roberto F. Gumanas Jr., Mr. Giovanni S. Elugso, and Miss Evelyn P. Pusod. We're from the College of Agriculture and Forestry of Jose Rizal Memorial State University, Katipunan Campus, Katipunan, Zamboanga del Norte, Philippines. Introduction. A propagation technique is demonstrated in many plant species, and when it comes to rose propagation, it is proven to perform better when the cuttings are treated with rooting hormones to hasten root initiation. A rooting hormone is used in plant propagation to grow new roots on cuttings, that is according to Pavlis 2016. They can be used to stimulate root development, control plant height in greenhouse investigation, and also increase the size of the fruit. Organic hormones are natural materials that possess the ability to stimulate the rooting of cuttings such as honey and etc. That is according to Shield 2012 and Caroseta 2014. Inorganic hormones such as ANAA, Hormex, and indole butyric acid work on a variety of cuttings, including new growth, brittle stems, woody stems, and others. They are also useful for grafting and dramatically increase the success of grafted plants. The objectives of the study was to evaluate the effects of rooting hormones on the root formation of rows. Specifically, it aims to determine the effects of organic and inorganic rooting hormones on the growth performance of cutting rows and to determine the rooting performance and survival rate of cuttings treated with inorganic and organic hormones. For methodology, this study was conducted at Barangay Tubacong, Tiazamo del Norte from June to September 2021. The treatments of the study are the following. Treatment 0, that is control, no application. Treatment 1, 1000 ml rice water. Treatment 2, 1/2 kilogram banana peel plus 2 liters water. Treatment 3, 1000 milliliters coconut water. And treatment 4, 0.5 ml ana hormone plus 1000 ml water. The experiment for experimental treatment and design. The study was laid out using a completely randomized design with 3 replications and 5 treatments. Each treatment consisted of 15 plants and only 10 plant representatives were selected for the data gathering and statistical interpretation. For statistical analysis, data was subjected to analysis of variance or ANOVA in completely randomized design with t-test or 2 key post hoc test. For the preparation of cuttings, healthy cuttings were taken and they should be from the upper part of the plant. For some reason, cuttings taken from the middle of the plant do not root as well. The stem that is 4 to 6 inches long and has at least 2 or 3 leaves shall be collected using sharp or pruning shears and make a clean slice at a 45-degree angle to minimize the rooting area. The flower or buds were removed from the cuttings as well as any lower leaves. The remaining leaves were cut in half to reduce moisture loss through a transpiration and using a pencil, make a small hole in the growing medium for the stem to fit into, gently tamp the cutting into place. For banana peel extracts preparation, the banana peel was collected from houses, bakeries, and fast food industries, which was further washed with tap water to remove the dust and any impurities to the outer surface. The clean banana peels were air dried for 1 day and were chopped into small pieces. Then 1/2 kilograms of banana peels was added with 2 liters of water. This methodology is according to Bakery 2016. The chopped banana peel was fermented for 48 hours at a room temperature. The banana peel extract was collected and was used as a treatment, that is according to Aurori et al. 2009. For rice water is derived from the process of rice washing. The rice was washed with water 3 times to clean the rice from the dirt. The first rinsing rice water was collected and 1000 ml was used as a treatment. That is according to Hariyadi 2019. The collected rice water was collected and fermented for 24 hours at room temperature. That is according to Orwa et al. 2009. For alpha-naphthalene acetic acid or ANA hormone, this hormone was bought in an aggregate supply. 0.5 ml ANA was added with 1000 ml of water. That is according to Gonzalez 2018. For coconut water was collected from Barangay Tubacong, Zamboanga del Norte, taken from fresh matured coconut fruit. It was collected early in the morning and was immersed in water for 4 to 6 hours to assure that it is effective. That is according to Ogates 2015. Afterward, 1000 ml of coconut water was collected and served as a treatment, according also to Lainian et al. 2006. For treatment application, 225 rose cuttings were used and distributed to 5 treatments in the study. These cuttings were simultaneously soaked for 15 to 30 minutes in various prepared solutions except the control. After soaking, all cuttings were planted immediately into the respective polybonds. For selection and or collecting suitable cutting. Rose cuttings were collected early in the morning and the leaves of the lowest half part of the cuttings were removed. The cuttings were not dried nor exposed to too high or too low temperatures. For the preparation of planting media, the planting medium of the study consisted of garden soil, sand, and organic compost in the proportion of 1:1:1 ratio. It was thoroughly mixed and sterilized for 30 minutes, that is according to Greenback et al. 2012, through exposure to sunlight and was poured into individual 5 by 10 polybag and was arranged according to the experimental layout. For planting of cuttings. Cuttings were planted early in the morning. All cuttings were randomly distributed inside a plastic polybag, 5 by 10 in size and properly arranged according to the layout. 225 cuttings treated with organic and inorganic rooting hormones were randomly planted in the polybag. Weeding was done when the weeds had started to emerge, and this was done manually. Sanitation and cleaning in the area was also periodically done. Watering was also done in the morning to allow foliage to dry quickly and to help prevent foliar diseases. These are the data gathered. Number of leaves, number of roots, length of roots in centimeters, length of shoots, number of shoots, and survival rate. For results and discussion. The first data is on the number of leaves in each treatment. Figure 1 shows the performance of 4 treatments. Treatment 3, coconut water, significantly showed the greatest number of leaves. This can be supported by the work of Leakey 2004, who noted that the cuttings that have a high level of auxins and cytokinins, just like in coconut water, have a higher percentage of cuttings that will produce more leaves. This response was also confirmed by Young et al., who showed that coconut water contains a content of cytokinins, which helps to stimulate leaves. It is followed by treatment 4, the use of ANAA, which had the same result. According to Ampuan 2006, which simply suggested that the effects of rooting hormones on the leaves' performance of rose cuttings are very prominent. And it is followed by treatment 2, the banana peels, which also produced leaves. It contains organic matter, 91.5%, as well as it has a considerable amount of protein, carbohydrates, minerals, antioxidants, and amino acids. And it is followed by treatment 0, according to Anandara et al. 2005, that without the application of any treatment, there is still a possibility that the cuttings will also produce leaves. The next data is on the total number of shoots. This figure shows the number of shoots that emerged that were carefully gathered and tabulated for statistical analysis. It was found that the treatment 4, the use of ANAA, produced more shoots with a mean value of 6, followed by treatment 3, coconut water, with a mean value of 5, followed by treatment 1, rice water, and treatment 2, banana peel, got the same produced shoots as the mean value of 4, while treatment 0, the control, with a mean value of 3. According to Mundan 2012, the study of Reusser et al. 2004 on the growth of Fraser Fair, ANAA significantly increased the number of shoots. Research conducted by Tuaptinaya et al. Showed that the application of banana peel extract has a significant effect on the number of shoots. This part of the banana has a lot of benefits because it has more potassium content than the other elements. The analysis of variance revealed that the application of organic and inorganic rooting hormones resulted in a significant effect on rose cuttings. Further, using a t-test or Tukey post-host test, it shows that treatment 3, treatment 2, and treatment 1 are not significantly different from treatment 4. This means that cuttings responded to various organic and inorganic rooting hormones, resulting in a significant result. The next data is on the length of roots in terms of centimeters. The next figure depicts the length of roots that emerge. It was found out that treatment 4, the use of ANAA, got the highest length of shoots with a mean value of 47.33, followed by treatment 1, the use of rice water, with a mean value of 44.03, while treatment 3, the use of coconut water, with a mean value of 42.5, followed by treatment 2, banana peel, with 42.23, followed by treatment 0, control, with 36.73 mean value. The analysis of variance, or the ANOVA, revealed that the shoots of rose cutting subjected to organic and inorganic rooting hormones had no significant effect. Further tests using the t-test or the Tukey post-host test, showed that treatment 0, treatment 1, treatment 2, treatment 3, and treatment 4 are not significantly different from each other. The next data is on the total number of roots. This figure here revealed that the rooting performance of cuttings in 90 days of observation. It was found out that treatment for the use of anaa has the highest mean with a mean value of 10, followed by treatment 3, the use of coconut water, and treatment 1, the use of rice water, got the same produced roots with a mean value of 9. This followed by treatment 2, the use of banana peel with 8, and the lowest was found out at treatment 0 in the control treatment with a mean value of 6. Reggie and Osman 2012 showed that anaa greatly influences the adventitious shooting in Stevania rebaudiana, a commercially important sweeting medicinal herb, and a higher concentration of anaa induces the maximum number of shoots within a short time. The analysis of variance or the ANOVA revealed that there is a significant effect on the number of root formation of cutting, and it was highly influenced by organic and inorganic rooting hormones. Further, testing using a t-test or the Tukey post-hook test shows that treatment 1, 2, 3, and 4 are significant to treatment 0. The next data is on the length of roots. This figure here shows the length of roots. It was revealed that the cuttings treated with treatment 4 with anaa got the highest mean value of 56.2, followed by treatment 3, the use of coconut water at 55.93. It is followed by treatment 2, banana peel with a mean value of 55.33. Then by treatment 1, the use of rice water with a mean value of 50.33, while the lowest was 30, the control. According to Mundan 2012, similar positive results were also observed that the highest length of roots is anaa in studies abroad propagating different tree species using rooting hormones. However, the performance of anaa in inducing the length of root development can be because rooting hormones contain auxin that induce both growths of roots. These results confirm that the rooting ability of Bourbon rose was sensitive to treatment 3, the use of coconut water application, due to the presence of cytokinins in form of zeatin presence in coconut water that stimulates cell division for the lateral dominance. The analysis of variance or ANOVA revealed that there is a significant effect of organic and inorganic rooting hormones on the length of the rows. Further, testing using the t-test or the Tukey post-hook test shows that treatment 1, 2, 3, and 4 are not significantly different from the control treatment or T0. The next data is on the survival percentage. The figure here depicts the percentage survival of cuttings as affected by organic and inorganic rooting hormones. It was observed that treatment 3, the use of coconut water, and treatment 4, the use of anaa, get the same number of cuttings that survived with 95.55%, followed by treatment 2 and treatment 1 with 93.33%, while treatment 0 had 77.77%. The coconut water treatment on cuttings has significant effects in increasing shoot length, the girth of shoots, number of leaves, dry and fresh weight of root, and root length. The use of banana peel and rice water also can increase growth and yield. Besides, they have no side effects and are environmentally friendly. On the other hand, rose cuttings can also survive even without applying any treatments, but there is a possibility that the cuttings will die even if they form shoots. However, if there is consistent proper care and maintenance, it will survive. It was also observed that the control also develops roots. Ampuan 2006 simply suggests that the effects of rooting hormones on the rooting performance of rose cuttings are very prominent. The analysis of variance showed that both levels of organic and inorganic rooting hormones gave significant effect, but at a 5% level of probability only. Further, testing using the t-test or Tukey post-hook test shows that treatment 4, anaa, treatment 3, coconut water, treatment 2, banana peel, and treatment 1, rice water are not significantly different from treatment 0. This means that treatment 4, treatment 3, treatment 2, and treatment 1 were statistically the same and comparable to each other. Based on ANOVA, the use of coconut water and anaa had the greatest effect on rose cuttings in producing a higher number of leaves, length of shoots and roots, several shoots and roots, and survival percentage compared to the other treatments. The higher concentration of anaa resulted in an increased number of adventitious rooting per cutting. Organic and inorganic rooting hormones were effective as rooting mediums in any cutting method propagation. In this study, anaa and coconut water are recommended at higher concentrations to produce several adventitious rooting per cutting and other growth parameters. And these are the literatures which were used in this study. Thank you very much, and God bless.
Thank you, sir. So there you have it, our fourth poster. So we are now opening the floor for question and answer. So there we have it, Sir Darwin.
Hello, sir. Good morning. Good morning, everyone, especially to our panel of judges.
Okay. So excuse lang daw muna si engineer. So we only have two uh, judges for this time.
Hi, good morning.
Morning, ma'am.
Okay, I will be giving the first question. So thank you for your presentation. Your title states there organic and inorganic hormones, right? So
Yes,
my
ma'am.
question is, did you test the materials used in the treatments on what kind of hormone do they possess that makes them suitable to be used as treatment here? You mentioned cytokinin for coconut water. Well, it's established in literature. Coconut water has cytokinin. How about for the other materials like the rice wash, the banana peel, etc.? So, what hormones can be found in them, or did you have them tested for their content, for their hormonal content? Ayun. Thank you.
Thank you for that question, ma'am. It's with regards to your question, it is no longer part of our study to test the composition of the organic hormones that we have used. We have just referred the composition or the compound in the literatures. So, as what I have mentioned with regards to the cytokinins and auxins, those were just found in literatures. And it is no longer part of our scope to determine the composition of these organic compounds um, of these organic rooting hormones that we've mentioned.
Mhm. Okay, thank you. But I don't know if I missed it. What, based on literature, what hormone is present in the banana peel, in the rice wash, and what's the other one?
Yes, ma'am.
Yeah,
For
please.
rice water contains um, vitamin B1, phosphorus, potassium, calcium, magnesium, sulfur, and iron. And a series of mutant genes and genetic mechanisms governing root development have been characterized in rice water.
Okay, but
While
no,
in
no hormone. So no, because when we talk about hormone, we usually think of the basic hormones: auxin, cytokinin, gibberellic acid, right? Because the contents that you mentioned are uh, not those hormones, the plant growth regulating hormones. Mhm. Okay, please continue with the banana
yes, ma'am.
peel, please. Thank you.
For banana peels, it contains also vitamin A, vitamin C, protein, carbohydrate, macro and micronutrients, phenolic compounds, and fiber. Um, it is reported also that banana peel or tryptophan as foliar treatment and different concentrations can grow under water deficit in quinoa plants, significantly increase photosynthetic pigments. And for coconut water, it is comprised mainly of water, while the rest being natural sugar, proteins, amino acids, good carbohydrates, vitamins, minerals, fats, fatty acids, and fiber. Coconut water also contains cytokinins and indole 3 acetic acid and gibberellins. That's all, ma'am.
Mhm. Okay, ayun. So, based on the literature, parang sa coconut water lang meron nung hormones, but no mention of hormones in the banana peel or in the rice wash. So maybe if you would be doing follow-up experiments, siguro pwede rin i-include yung mga ganun. So what's really in those materials that would contribute to better rooting? Ano, kasi hormones talaga yung para doon sa rooting, sa shooting. Thank you.
Noted, ma'am. Thank you, ma'am.
Sir Franz?
Okay, good morning, Darwin. Thank you for the presentation.
Morning,
Okay,
sir.
I just have a quick question when it comes to the methodology. In terms of using the water, were you able to consider the testing the water? Kasi I think water is very crucial as well in the experiment. That's one. Second, in terms of the treatments, I observed that you used 2 liters of water for banana peel, while whereas the others were 1 liter. So, would like to ask why is it that 2 liters were used in the banana peels? And yeah, those muna.
Okay, sir. Thank you, sir. With regards to water, um, the quantity of or the volume of water, especially for banana peel, we have just taken this one from the study of Olanian et al. And so for the anaa, we have mixed it with 1 liter water. We have also coined this methodology from the study of Gonzalez 2018. And so with regards to your question as to if we tested the water, we were not able to test since that is also part of our study. We have just coined it from the previous studies.
Okay, thank you for that.
Thank you,
Then, in
sir.
terms of choosing the the material, the plants or the rows, how did you come up with this? Is it the same variety? Is it where did you source it out?
With regards to the source of these cuttings, since this is just locally available here in our locality in Zamboanga del Norte, so we have decided to use this one in our study because it is not much commercially cultivated, especially here in our area. And we all know that this variety of rose is very much I mean the production of this variety of rose is not much practice in our locality, and so we will um, try to study the procedures on its production.
Okay. May follow-up questions pa po ba from our
Yes.
judges? Yes,
Mhm.
Miss Anne.
Uh, um, you I think in the summary you identified coconut water and also the ANAA as the best among the treatments. But did you try computing the cost? Kasi for example, coconut water, pinibili kasi din yon and mahal siya. Actually, we tried using it in another experiment and bulk of the gastos was really the coconut water kasi bibilhin talaga at mahal ang buko juice ngayon. Ayun. So, did you try computing the cost? Kasi kung parehas lang yung effect nung commercially available na ANAA doon sa coconut water, baka mamaya mas mura pa lang, bilhin na lang yung commercially available. Then, go with coconut water na mahal nga kasi ginagamit din siyang juice. Ayun. So, did you try computing things like that also? Thank you.
Thank you, ma'am. With regards to the computation of the return on investment, we were not able to include that in our study, and possibly we will just include that one in our recommendation for further studies, ma'am.
Ayun, okay. So, magandang isama yun kasi if it's being targeted to be applied by yung mga nagtatanim ng rose. So, alam nila na saan sila mas makakamura na effective pa rin. Ano? Thank you.
Yes, ma'am. Noted,
Okay.
ma'am. Thank you, ma'am.
So kung wala nang question ang ating mga judges, so we can have some questions from the Facebook. So we still have 6 minutes for the question and answer. Okay, this one is from Sir Alkin Uy. As a research based in your results, are you recommending to use ANAA chemical as compared to other organic sources of plant hormones? And did you consider also the economic aspect of your study? I think related din doon sa question kanina ni Miss Anne. Sir Darwin, would you like to respond to that question?
Yes, sir. The economic aspect, we were not able to include that one in our study. And
Mhm.
so we hope to include that one for further studies na lang po. Thank you po.
And it means that you are recommending the ANAA based on the results. Is that right?
Yes, sir.
Okay. So next question is from Ma'am Irene. Is there any correlation between the number of shoots, length, and number of roots to the yield or number of produced flowers? So flower producers would resort to your recommended treatment. So very practical ano to question, sir.
Hello, sir.
Please proceed, sir.
Hello po. I think the connection is lost po.
Okay, can you hear me, sir? Sir Darwin, can you hear me? Can you hear me, sir? Hello, Sir Darwin. Miss Anne, Sir Franz, can you hear me? Okay. So, I think yung connection ni Sir Darwin yung may problema. Okay. So, nawala yata. Nawala ba si Sir Darwin? Okay. Habang naghintay kay Sir Darwin, kasi we still have 3 minutes ano sa question and answer. So, I would like to invite yung ating mga participants doon sa ating Facebook at YouTube to check our virtual poster found in our website. So, I already posted in the Facebook the link kung saan po natin pwedeng makita yung ating virtual exhibits. So para makita nyo yung kanilang mga posters na pinresent po kanina. And also later, we will be uploading yung presentation po nila. Doon din po sa the same link, doon sa ating PAA website. So, explore nyo po yung ating virtual exhibits. Makikita nyo po dun sa bandang dulo. Pasok po kayo dun sa ating virtual exhibits. Makikita nyo po dun sa bandang dulo yung mga poster papers po natin. Nakapost po siya doon. Okay? So, ayan, nakabalik na si Sir Darwin. So, we can continue yung questions from our Facebook. May question pa po ba tayo dun sa Facebook? Sir Darwin, naririnig mo na kami?
Yes, sir. Kakabalik lang po. I think
Okay.
the connection is low, sir.
Okay. So, ito yung last question natin ano kanina yung nung nawala ka. So, is there any correlation between the number of shoots, length and number of fruits to the yield or number of flowers produced? So, yun po yung question ni Ma'am Irene kanina.
Thank you, Ma'am Irene, for that question, ma'am. We are very glad to hear this question. And based on our study, we were not able to include the correlation. Possibly for further studies po, we will include a correlation between the growth parameters and its number of flowers because it's from the yield and from the growth. This will correlate to the yield aspect of rows. So for further studies po, we will include the correlation po.
Okay. So, we can still have two more questions. Next question is, what is the essential component of coconut water that encourages rooting? Do you believe that the time employed in soaking has an impact on rooting? Do you believe 15 to 30 minutes of soaking is sufficient? I think medyo related yung question na to kanina doon sa question ng ating mga judges, but may mga questions siyang very specific. Sir Darwin, please.
The essential component of coconut water, sir, as what I have mentioned earlier, coconut water po has a natural growth regulating hormones that contain phytohormone such as cytokinins and indole-3 acetic acid or the IAA, and also it has gibberellins. For succeeding question, the time employed in soaking, this is 15 to 30 minutes. Um, well, according to literatures, and it has also, by the way, sir, it has also zeatin or oxine, coconut water. And according to literatures, the use of or the time spent in soaking the coconut, which is 15 to 30 minutes, is sufficient. That is according to the previous studies.
Okay, sir. Thank you. So, wala na po tayong time for the questions. So may nag-question lang kanina dito kung curious yung kasama natin dito sa PAA. So kung yung daw bang rose na napoproduce mo, Sir Darwin, using yung sa experiments mo, pag binigay daw ba dun sa nililigawan ay sasagutin? Kanong nililigawan?
Posible po.
Depende daw kung may nakaipit na pera dun sa may rose.
Ah, parang
pero
ganun
joke
na rin po.
pero joke lang po 'yon ano para lang po to lighten our presentation. Okay? So
Thank you
thank you
po.
Sir
Thank you.
Darwin. Thank you po.
Thank you, sir. Thank you, everyone.
So moving to our last poster for this morning. So can we have the last poster? Poster number 5 entitled Vegetation Propagation of Lemon Using Organic Plant Growth Regulators. This will be presented by Mr. Ched R. Caperida of the Jose Rizal Memorial State University, Katipunan Campus, Zamboanga del Norte. Kasama po niya sa paper na ito si Miss Connie Marapaw and Miss Bianilin B. Lomoxo. Okay? Can we have the video of Sir Caparida? Caperida.
Good day to everyone. I will be presenting a research conducted titled Vegetative Propagation of Lemon, Citrofortunelia microcarpa, using organic plant growth regulators. The researchers are Professor Ched R. Capirida, Miss Kuni Marapaw, and Miss Bianilin Lumokso. So on their behalf, I, Roberto Flores Gumanas Jr., a licensed agriculturist, will be presenting their research topic. Lemon cultivar belong to Rutaceae family, the genera Citrus, orange, Unicerus, trifoliate oranges, contain the principal commercial species. Presently, nurseries are experiencing a shortage of seeds for some of the popular rootstock varieties, and vegetative propagation methods are required to produce large numbers of genetically identical plants. Modern agriculture is searching for new tools that would allow for a reduction in the use of chemical inputs without negatively affecting crop yield or the farmer's income. Natural plant extracts, which are rich in plant hormones, can be used to improve and stimulate growth of other plant species. Objective of the study. The study aimed to determine the efficacy of aloe vera extract, honey, and brown algae seaweed extracts as organic plant growth regulator on vegetative propagation of lemon. Research method and design. Lemon or Fortunella microcarpa cuttings was used in this research and were collected from the province of Misamis Occidental, Philippines. The experiment was conducted during July 2021 and lasted in September 2021. Under mini greenhouse with an area of 17 square meters. It was placed in 15 poly propagation chambers measuring 50 centimeter by 60 centimeter. Complete randomized design was used in the study. Its replication contained 15 plant samples, including the excess plants. The extract was filtered and sterilized. Brown algae extracts were prepared in a way that 250 grams of air-dried brown algae were added to 800 ml of distilled water and were boiled for 15 minutes. A semi-hardwood cuttings was collected with uniform size containing 4 buds. It was planted at 5 centimeter depth on a recycled plastic bottle filled with sand at 1 kilogram in capacity to form rootstock. As a parameter, plant height was measured through centimeters during the termination period using a roller. Root length was measured by placing the root flat on a clean board during termination period. Weight of cutting was done by weighing all the cuttings before planting and also weighing the 10 selected representative cuttings during termination period. All the data gathered were analyzed using analysis of variance or ANOVA. Results and discussion. So the response of the lemon cuttings on some growth parameters using various organic plant growth regulators. Figure 1 shows the response of lemon as to their height of the lemon cuttings. It shows that aloe vera extract and brown algae extract produced a significantly taller lemon than and were comparable with each other. While honey and anaa were statistically at the same as the control and lower than the two previously mentioned treatments. The aloe vera and brown algae, the result implies that these two organic regulators are capable of influencing the height of the lemon cuttings. This result is in agreement with the study of Faldea 2017 that the use of aloe vera extract can increase the plant height. The higher growth observed could be attributed to GA3 found in aloe vera plant. Figure 2 shows the number of leaves of lemon cuttings in response to various treatments. During 25th, 40 days, and the 65th day of transplanting. Analysis of variance or ANOVA shows significant result at 5% level on the number of leaves at 25th day after transplanting. Testing further all pairs, Torquay HSD shows that aloe vera had the same effect on the number of leaves with ANAA hormone, followed by brown algae extract, while the aloe vera extract and honey are comparable to the control of new treatment. These results were supported by Safari et al. 2004, who observed inhibition in shooting a number of leaves with increased concentration of ANAA in other species. Root length of lemon was shown on figure 3 as response to various treatments. It shows that root length of lemon cuttings after the analysis of variance indicated that the root length of lemon cuttings was significantly affected by brown algae extract with 6.9 centimeters, followed by the use of aloe vera with 6.3 centimeters. Testing further all pairs, Torquay HSD shows that the brown algae extract and aloe vera extract, as well as the ANAA, are comparably of the same root length. The three treatments possess same effect on the root length of lemon cuttings. According to Pramanik, 2012, seaweed extracts such as Celtic and other type of seaweeds affect various aspects of growth and roots and development, including overall health of the plants. Figure 4 shows the number of roots of lemon cuttings in response to various treatments. And it shows that brown algae extracts has significant effect on the number of roots produced with 14 roots, followed by treatment 4, which is the ANAA, that produces 11 roots. And treatment 1, aloe vera, which produced 10 roots, and the treatment 3, honey, with 10 roots produced. The lowest number of roots was noticed in treatment 0, with 6 roots produced. Analysis of variance or ANOVA showed a significant result at 5% level on the same number of roots produced of lemon cuttings. Testing further, using all pairs, Torquay HSD showed that brown algae extract gave a significantly higher number of roots displayed superiority as to other treatments. According to Smith, 2013, when used at the root zone, seaweed stimulates cell division and root cells, resulting in more lateral root growth and root mass. Figure 5 shows the rooting percentage of lemon cuttings in response to various levels of treatments. Analysis of variance shows highly significant result at 1% level of rooting percentage of lemon cuttings. And testing further, all pairs, Torquay HSD, the rooting percentage of lemon cuttings was significantly affected by brown algae extract with 82% of rooting capacity, which is slightly higher than ANAA hormone with only 80% of rooting percentage, followed by aloe vera with 73% of, and honey with 71%. This means that brown algae extract and ANAA hormone are statistically superior and comparable to each other. In the other hand, aloe vera, honey, and control manifest comparable results and shorter than the two treatments. According to Verneri, 2005, an improved root system could be influenced by endogenous auxins as well as other compounds in the extract. Figure 6 shows the survival rate of the lemon cuttings in response to different treatments. And it shows a highly significant result at 1% level on the survival percentage and testing further using all pairs. Turkey HSD showed that brown algae and ANAA hormone are almost the same effect on the survival rate. Other organic solutions also improve the survival rate of lemon cuttings in comparison with the control. This implies that all organic treatments affected the survival percentage of lemon cuttings. This result is in agreement to Longman, 1998, which state that general, natural, and synthetic auxins hormones have a positive effect on the overall growth of cuttings. In conclusion, lemon or Citrofortunella microcarpa responded differently to the different treatments solutions. As noticed on almost all parameters, namely the number of leaves, survival percentage, root length, and the number of roots, and the rooting percentage were improved by the brown algae extract as organic solution in comparison with other organic solutions and even comparable with the use of inorganic hormone, which is the ANAA. When it comes to recommendations, based on the results of the study, the researchers suggest using the brown algae extracts as plant regulators in the vegetative propagation of lemon. The researchers also recommends a follow-up study for a longer duration to further investigate the other possible effects of using organic plant growth regulators on the vegetative growth of lemon. So that concludes my presentation and good day.
Okay. Thank you, Mr. Caperida, for that presentation. So we are opening the floor for questions. Ayan.
Hi.
Ayan, nakabalik na si engineer.
Hello
Okay.
po. Good,
Morning. Okay,
good
I
morning
will.
po.
Mhm. Can I give the first question?
Yes, ma'am,
Yes po,
and
yes
please
po.
proceed.
Okay, so this is similar to the previous study, so using different sources of hormones or plant growth regulators. So my question uh, is also similar. Did you test the materials used for what kind of growth regulators they contain, or based on literature, what hormones or growth regulators do they have? The brown algae, etc. Thank you.
Good morning, ma'am, and thank you for that question, ma'am. As to testing, ma'am, yes, we did not include that in our methodology, but yes, we support, we read more literatures about the possible functions of the following plant growth regulators, and as I read in the literatures, aloe vera possess gibberellin-like compound, which is believed stimulates cell division and stem elongation, as cited by Verma. And then another one, the parenchymal gel of the aloe vera extract also contain enzyme, amino acid, and sugars. That's for the possible content of the aloe vera. Now for the seaweeds, based on our literature, still it possesses auxin, cytokinin, and gibberellin, uh, which we believe it also stimulate cell enlargement and stem elongation and initiate growth initiation. And then for the cytokinin, again, it also promotes cell division and stimulate shoot proliferation. Then for the honey, as what we read, it has a good antibacterial and antifungal property that protect the cutting from pathogen and allows the natural rooting hormone in the cutting to stimulate root initiation. And anaa is an example of synthetic auxin. It's also stimulates cell enlargement. So those are the possible functions of the plant growth regulators that we included in our study. But as to testing, ma'am, we did not undergo it with
Mhm.
testing.
Okay, thank you po. Another question lang po, because in your recommendation, pinaka-okay yung ating brown algae, no? Tanong ko lang po, how easy is it to
Prepare.
access or how available is it kung
Okay.
itatry ng ating ibang lemon
Okay.
growers?
As to the availability po, first, the seaweeds is very rich in our shoreline because our shoreline here in Mindanao is hindi po siya masyadong disturbed. Napakarami pong seaweed sa amin dito. And then as to the preparation of the seaweeds based on the methodology, the researcher used 250 grams of seaweeds and then deboiled it, mixed it with 800 liter of water, and then from that, the researcher just um, get measure 10 ml of that, and then the researcher diluted it to 1 liter of uh, water. That's how the researcher prepared that uh, compound as growth regulators in the cuttings of uh, citrus or calamansi.
Okay, thank you po. And it's a good thing marami kayong readily available seaweed sa area to be used
Yes po.
for, yes. Mhm.
Yes po, marami po
So,
sa amin, ma'am, dito sa Mindanao.
so posible kaya yun magagamit din for areas na walang masyadong supply ng seaweed? Ano ba yung pwede bang i-process yung seaweed into something packageable form? Pag gusto gamitin ng, say, nasa kapatagan, wala silang access sa mga dagat natin. So,
Uh,
pwede kaya yun?
yes. Yun po ang siguro problema sa mga areas na medyo hindi po rich yung materials nila. So siguro baka naman po may magko-commercialize na diyan kasi of the availability of materials at magiging available na po sa market. Hopefully,
Eh,
one of these days mangyari yun.
okay. I think it's good na meron ngang mga ganitong experiments or researches. So para makita natin yung potential nitong ating mga natural resources and if they could be possibly commercialized para rin marating natin yung ibang possible end users. Salamat po.
Yes po. Thank you din po, ma'am.
Thank you, Miss Anne. So, who would like to ask the next question? Sir Franz or Sir Joseph?
Sige pa.
Yes, Sir Franz.
In relation to the question of Miss Anne po, no? So, it's good that it's easily sourced out yung algae natin. I would like to ask, in terms of choosing the resource, is it the same in terms of variety? Have you
As
considered
this
that? Is it
as yes sir, as described by the researcher sir, she's using the brown seaweeds, the very common seaweeds
very
in our shoreline, the brown
so it's
seaweeds.
okay? It's
Yes.
naturally growing.
Yes po, sir. And very rich in
Okay.
our shoreline.
The aloe vera, sir. What variety were you able to use?
As to the variety, sir, it's not mentioned in the methodology, but I think the common aloe vera that is planted in one part of the ornamental plants in every household. I think that's the kind of aloe vera that the researchers using. The common aloe vera, not
My
the
next
hybrid.
okay, thank you, sir. Relevant to that, were cost tama po no sa study hindi natin nasama yung cost analysis natin. But in terms of accessing the aloe vera naman, is it cost efficient?
Mm, yung aloe vera po, sir, parang parang napaka-common po siya kasi parang sa every household yung may mga nagtatanim ng ornamental, parang kasama po siya sa ornamental nila, sa bahay nila. Parang common lang po siya, yung aloe vera sa amin. Parang common ornamental plants po siya sa amin, ang aloe vera. Kasi hindi yung aloe vera na ano sir, yung commercially available sa market. It's a gel extracted from the leaves. No? It's a fresh aloe vera, yung aloe vera plant na ginagamit nila. So parang common dito sa amin yung aloe vera.
Asking for replication, syempre, if ever, maganda na malaman kung ano talaga yung specific. Tapos, how much our costing. I have another question. Kasi you're recommending to subject it for a longer period. Um, how much longer are you intending to, based on your study?
Yes, the total period for this study, sir, covers 65 days only. Now, if I will recommend to the student or to the researcher, maybe up to 90 or 100 days in order to roll out and to validate further the possible growth manifestation or growth performance of the cuttings. Because as to the number of roots, after 65 days, the cuttings only produce four roots based on the data. Then as to the number of leaves, 4 leaves only. So if I would suggest, much better if they will extend it to 90 or 100 days to roll out the possible or the potential effect of these growth regulators to the cutting performance of lemon or citrus.
Okay. Okay ka na, Sir Franz? Okay. Engineer Joseph, would you have any question?
Sorry po ha kasi hindi ako naka-join kanina doon sa isa. May
Okay.
dumating lang yung aming
Okay lang, sir.
very important bisita.
Okay lang, sir.
Good morning, sir. Good morning.
Good morning po. Question ko siguro doon sa result ng survival percentage, yung walang anything, siguro tubig lang yun, tama ba?
Yung sa control po, sir.
Yung control, it's
hindi po
around
subject
70%.
Yung shooting rate at saka yung rooting number of routes, length of routes. Wait. Yes, sir. 71% yung sa control, sir.
Ayan, so narinig ba ako?
Yes, sir. Yes, sir.
Nalobat. 70% and then yung brown algae is around 85.
Yes.
So it means kung meron akong 100 plants, lumamang siya ng 15 plants.
Yes.
And then doon sa binili ko na ANA, nasa ano lang din siya, 90 or 87. 89.
Yes, yes po.
Do you consider it, although sa data naman, ano siya, di ba, B yung C yung control,
Yung
80
control.
brown.
Yes,
so, significant sila, Pero,
yes po, yung seaweeds.
Business-wise, although hindi nyo nga ito kinapture siguro, pero looking at on the application talaga, do you think siya magiging with considering all yung preparation, kukunin mo siya sa dagat and hindi ba kaya mas okay na bumili na lang ako nung available? Or ano yung mo? Ano yung idea mo doon?
Yes, sir. When it comes to practicality, parang ganun po siya.
Practicality. Or wag na lang ako maglagay
yes.
kasi kaya ko makabuhay ng 70 out of 100. So hindi na siya masama.
Yes, parang ganun po ang parang yung implication diyan, parang ganun. But anyway, the student have the option. So if in their area ANA is not available, then they can have an option to use seaweeds. It depends on the situation, sir. But yes, practicality, kung meron naman pong ana, parang gano'n na po ang mangyari. I prefer to choose ana than the
Okay.
seaweeds.
But still this is a good ano nga, this is a good experiment din. And siguro base din dun sa inyong recommendation kung kaya pang ma-improve, there's still room for improvement. Meron pang namatay ng 7 na 30 baka walang green thumb yung nag pero hindi, joke lang. Kaya pa siya kung halimbawa ma-optimize mo yung process. I think magagawa pa siya ng ano, may improve pa siya kasi kahit dun sa Anaam 11 plants still ano yun very important pa din. So yun lang naman comment ko.
Sige po, sir.
Okay, so we still have 2 minutes. So can we have maybe one question from the Facebook? Ito from Sir Carlo Alfonso. So how did you identify the lemon variety daw, Sir Ched?
Mm, Actually, as I asked the students of why she's using that no that variety, the Citrophonelia microphora, and she answers that variety is available in their area. That's only the available mother plant or variety in their area.
Okay, sir.
So that decide her to use that mother plant as source of cuttings. But dito naman po sa Mercer, sa Sampen, emerging crops po ang limon or citrus sa amin, especially sa neighboring provinces sa Sibugay. Yun po ang banner commodity nila. At sila yung nagsusupply sa amin sa Dipolog City ng process at saka fresh. Minsan pa nga umabot sa Manila yung products nila.
Okay.
Yun po ang industry ng limonsito sa amin.
Okay. So that's it. So that is our last poster for this morning and for this Congress. So thank you, Sir Ched, and
Thank you,
thank
Pindi
you to
po.
our panel of judges. Thank you for joining us and helping us evaluate and see the outputs and the merits of these posters. So thank you, sir.
Thank you. Thank
Sir.
you. Maraming salamat, sir. Thank you. Thank you sa inyo lahat dyan. Maraming salamat.
So thank you kay Sir Franz, kay
Thank
Engineer
you.
Joseph at kay Miss Anne. So wag po muna kayong umalis sa ating mga judges. So we will award po ang inyong certificate later. Okay. Thank you, Sir Ched.
Thank you, sir. Thank you.
Okay. So moving forward, so we would like to award certificate of appreciations. Certificate of appreciation to our uh, evaluators, judges. So the first certificate goes to Mr. Joseph and Sandro. So let me read the citation. So the Philippine Association of Agriculturists Certificate of Appreciation is awarded to Engineer Joseph M. Sandro for serving as judge during the poster paper presentation. Given this 22nd day of July 2022 during the Second International PAA Virtual Congress and 2022 Agriculturist Summit. Signed, Dr. Roberto F. Ranyola Jr., the Board of Trustees Chairman, and the National President of PAA, Dr. Louis A. Divina Gracia. Thank you, Engineer Joseph. And we will just send to you our token of appreciation. So, padala na lang po namin, Sir Joseph, sa inyo. Okay. So,
Welcome po.
kapitbahay mo daw si Sir Mon. So, sa kanya na lang namin ipapadala.
Apa.
So, next certificate is awarded to Miss Anne Malulex Magnaye. Thank you, ma'am, for your time. So allow me to read the citation. The PAA, the Philippine Association of Agriculturists Certificate of Appreciation is awarded to Miss Anne Malalulex Magnaye for serving as a judge during the poster paper presentation given this 22nd day of July 2022 during the second International PAA Virtual Congress and 2022 Agriculturist Summit. Signed, Dr. Roberto F. Ranyola, Chairman of Board of Trustees, PAA, and Dr. Louis A. Divinagracia, National President of the PAA. Con- co- Congratulations, Ma'am Ann. And thank you po pala. Hindi pala congratulations.
Thank you din po.
Oo. Next and but not the least is our certificate to Sir Michael Francis Falconi. So the Philippine Agriculturist Association, the Philippine Association of Agriculturists. Sorry, na bubulol na ako. Philippine Association of Agriculturists Incorporated Certificate of Appreciation is awarded to Mr. Michael Francis Falconi for serving as judge during the poster paper presentation given this 22nd day of July 2022 during the second International PEA Virtual Congress and 2022 Agriculturist Summit. Signed, Dr. Roberto F. Ranyola, Chairman, Board of Trustees, Dr. Louis A. Divinagracia, National President, PAA. So that's it. Can we have a photo opportunity for our judges? Okay.
Congratulations sa presenters and to
Yes,
PAA.
okay, congratulations po sa ating mga presenters. Thank you, sir. So, one, two, three, smile. So, there you have it. Thank you po sa ating mga judges. So, yung pong aming token will be sent to your to your offices. Thank you po. Okay.
Bye-bye po.
Bye-bye, sir. So moving
Bye-bye.
forward, we would like to award our certificate of appreciation to our poster paper presenter. So first, we would like to award the certificate of appreciation to Mr. Melvin S. Andres for presenting a paper on enhancing rice productivity in rain-fed lowland using modern production technologies during the second International PAA Virtual Congress and 2022 Agriculturist Summit on the 22nd day of July 2022. Signed, Dr. Roberto F. Ranyola, Chairman, Board of Trustees, and Dr. Louis A. Divinagracia, National President, PAA. Congratulations to the team of Mr. Melvin S. San Andres. Next certificate. Certificate of Appreciation is awarded to Miss Melissa P. Montecalvo for presenting a paper on mycosis of resulting neonates of true armyworm, Mytimna separata, eggs due to entomopathogenic fungi during the second International PAA Virtual Congress and 2022 Agriculturist Summit on the 22nd day of July 2022. Signed, Dr. Roberto F. Ranyola, Chairman, Board of Trustees, and Dr. Louis A. Divinagracia, PAA National President. Congratulations to the team of Miss Melissa P. Montecalvo. Next certificate is awarded to the team of Dr. Lucrecia A. Pontillas for presenting a paper on efficacy of various substrates on the growth and yield performance of gray oyster mushroom during the second International PEA Virtual Congress and 2022 Agricultural Summit given on this 22nd day of July 2022. Signed, Dr. Roberto F. Ranyola, Chairman, Board of Trustees, Dr. Louis A. De Vinegracia, PAA National President. Congratulations po sa inyo, Dr. Pontillas. Next certificate is awarded to the team of Mr. Darwin J. Lahera for presenting a paper on effects of organic and inorganic rooting hormones on the propagation of Bourbon rose during the second International PAA Virtual Congress and 2022 Agriculturist Summit. Given on the 22nd day of July 2022, signed Dr. Roberto Ranyola, Chairman, Board of Trustees, and Dr. Louis De Vinegracia, PAA National President. Congratulations po, Dr. Mr. Lahera and your team. Last but not the least, congratulations to the team of Mr. Ched R. Caperida. Certificate of Appreciation is awarded to Mr. Ched R. Caperida for presenting a paper on vegetative propagation of lemon using organic plant growth regulators during the second International PAA Virtual Congress and 2022 Agricultural Summit given on 22nd day of July 2022. Signed, Dr. Roberto F. Ranyola Jr., Chairman, Board of Trustees, and Dr. Louis A. De Vinegracia, National President, PAA. So again, congratulations to our paper presenters and thank you to our uh, judges. So again, may we remind our participants in the Facebook and YouTube to sign in our attendance and also to check our virtual exhibit. So kanina na-post na po yung link sa ating virtual exhibit. Ayan po, naka-post po siya ngayon sa ating screen. Or you can just simply go to our website, yung ating pong paa.ph paaph.org. So nandun po 'yon. Makikita nyo po doon yung ating virtual exhibit. So that will end our poster paper presentation for this Congress. And I will turn over now the floor to Sermon, our MC. Thank you very much for joining us.
Thank you, Ronnie, and congratulations for a organized poster presentation. Thank you to all the judges. Padalhan mo ng rose na galing sa routing si Ann. Uh, okay, so that concludes our morning session. We expect everyone to log in for this afternoon's activity, and this will be the formal opening ceremonies of the Congress, followed by the different plenary sessions. We have invited a lot of experts to discuss some of the relevant topics related to our convention team. Again, don't forget to sign up on the attendance sheet. And later this afternoon, we will also ask you to fill up the evaluation sheet. Okay. So before we end, again, we would like to thank the sponsors or our supporters for this Congress. We thank Picard, Leeds Agri, HIPRA, Nature Tech, and Sherka. Okay. Now, let us all meet this afternoon. You can start logging in to the online platform at 1 o'clock, and we will have our opening ceremonies at 1:30. So enjoy your lunch and see you this afternoon. Thank you.